Hi students, welcome to Vedantu NEET English. I am 𝐂𝐡𝐞𝐤 𝐎𝐿, your chemistry master teacher, and how are you all? Welcome and very good evening. Now today is the day one where students we are going to solve the most important previous year questions. You will see a trend, a pattern that is being repeated again and again, the same kind of questions that they are asking again and again repeatedly, right? So we are going to focus on those topics, and you know what, after today's lecture your knowledge will be enhanced. You will get to know what are the most important topics of inorganic chemistry. Third is, there are some questions especially in block chemistry which will be asked as it is, okay, as it is. They will be asked in your NEET 2025 exam, because in block chemistry they can't change the trend, right? So what they can do is just ask the same question as it is. Maybe they can mold the language of the question, or maybe they can ask the question in a match the following or something like that. They can just twist the question by changing the language, but they can't change the exception, right? So that is going to be the same. So these are going to be our top questions from inorganic chemistry. Okay guys, is everybody ready or not? Everybody in the comment section, are you all ready or not? Yes students, everybody. Chalo. Shall we start the session? Shall we start the session? Ready, ma'am? Ma'am, when will the class will end? Yeah, what is this? What is this funny question you guys ask? Huh? When I enter the class directly, ma'am, when will the class will end? Right? Beta, you have questions. You really want to gain the marks, na? So marks will not be gained in 1 to 2 minutes, right? Or in 1 hour. We are talking about important questions of complete inorganic chemistry. Definitely it is going to take 2 to 3 hours. Okay? Yes? Chalo. Okay, then let us start the session. But one request to all of you, that please just take one notebook, right, wherever you are writing, or one page, and write down the important topics from there. Right, when we are solving the previous year questions, by analyzing that, I'm going to give you some topics that you must do. Right? Okay. Understood the concept from where the questions are frequently asked. So you should write that. There is no use if you're not writing the most predictable topics. Right? Okay. Chalo. Now let us start the session without wasting any time. On your screen, the number one is, bacha, these are going to be pure questions, right? Okay. So as I asked you, don't get demotivated. Maybe you won't be able to answer even like one question out of this. It's okay if you're not able to answer. At least you know that these kind of questions will be asked in the exam. Now you will have the time to prepare for that, right? So take this as a lesson. Don't take this as a challenge. Okay, this is not something that you need to judge yourself based on this particular lecture, that I was not able to solve these questions, so that means I don't deserve this. That means I will not watch the lecture only, right? So don't get into that trap, right? Focus on the questions. If you're not able to do that, it's okay. See what I'm explaining and understand that, and make sure if the same question is asked in your NEET 2025, that you will not make it wrong, right? Or the same topic is asked, then you will not get it wrong, right? Okay, so the first question on your screen is, among the following, the electron deficient compounds is. So guys, these questions, firstly, write the topic, that is Fajan's rule, okay? The topic is Fajan's rule. The ionic character, covalent character, based on the Fajan's rule, electron negativity, they can ask you, arrange them in increasing order of ionic radius, covalent radius, which has more ionic property, covalent property, right? So these kind of questions are frequently asked in your NEET, and very simple questions are asked here. Right. So the first question on your screen is, out of the following, electron deficient compound. Okay. So this is not Fajan's rule. This is basically electron deficient compound. So if you talk about the general chemical properties and trends, right? If you talk about CCl4, we know that here it has 8 electrons. Here also it has fully fledged, like more than 8 electrons only, it has 10 electrons, right? Here it has lone pair of electrons. But if you talk about BCl3, in this case, it has 6 electrons, right? because 1, 2, 3, 4, 5, 6 and there are no lone pair of electrons on boron. That is why the compounds which has boron are acting as a Lewis acids also, right? Because they are electron deficient, right? So they can also ask you which of the following is a Lewis acid, right? Which of the following is a Lewis acid. They can also ask you this. You can just write it here. Which of the following is a Lewis acid? See, our focus is not only solving the question, but also trying to understand what other questions they can ask you based on this particular question. So they can ask you which of the following is Lewis acid, which is electron deficient. That way you will have to see. But if you have any boron compound, that will be electron deficient only, right? Next, you have which of the following is electron deficient. Again, they can ask you which of the following is Lewis acid, right? Which of the following is Lewis acid. Now, here beta, as you can see, this is silicon, then you have boron, then you have PH3, then you have CH3. As I told you, if you see any boron compound, right, that is going to be electron deficient, right? For B2H6, we also have a structure where it is forming, basically the answer is BH3 twice. I'll tell you the structure here. If you see the structure here, right? See, students, just by learning the exceptions, if you want to score full marks in inorganic chemistry, then just exceptions are not going to do the work for you, right? For that, I am not asking you to do the reactions of compound, but yes, some boron compounds, the structure you have to remember. And this is one of those structure which you have to remember for boron compound, that is diborane. Now, what are the specific things about this structure from where different questions are asked based on this structure only, right? So here different things are. First is, it is having BHB, two BHB bonds. This is BHB bond. This is also BHB bond, right? And these two bonds are called the banana bonds, right? These two bonds are called the banana bonds and they are bridge bonds. That means they are acting as a bridge between two molecules. But this HBH bond, these are your terminal bonds, okay? These are your terminal bonds. That is why we say one more question that can be asked is banana bonds or terminal bonds, or other is bridge hydrogens. So these are your bridging hydrogens because they are acting as a bridge, and these are the hydrogens that are at the terminal positions. These are your terminal hydrogens, okay? This question also can be asked. Third question that can be asked from here is, what are three-centered two-electron bond? What exactly is this? So this is three-centered two-electron bond, right? How many three-centered two-electron bonds are there in borane, diborane? Okay. So, then for this, what you need to remember that here, this is basically, if you talk about this particular bond, this is B1, 2, 3. It is having three centers, 1, 2, 3. It is having three centers. But can you see one thing, that electrons are only 2, right? In this three centers, which you have 3 electrons, and it is having only 2 electrons that are going here and there. That is why it does not have, we know that if you have 3 centers, then it should have 4 electrons, but it is only having 2 electrons. That means it is definitely electron deficient. So that is why answer will be B is the correct answer, okay? So I also told you what other questions they can ask you from diborane. Got it? So write the structure, write it in your notebooks, structure of diborane. Okay, write it in your notebooks, structure of B2H6. Okay, structure of B2H6 is very important. Okay, all the 3-centered 2-electron bond, banana bonds, that is banana bond only. So from there also question can be asked. Now, next is you can write it on your notebook, Fajan's rule, right? Ionic character, covalent character, how the questions can be asked, right? So concept will also be cleared by this video, right? Now, the concept is the correct sequence of increasing covalent character is represented by covalent character, guys, right? More is the ionic character, less is the covalent character. Ionic character is directly proportional to the differences in electronegativity. So covalent character is inversely proportional to the difference in electronegativity. Where you have less difference in the electronegativity, that is going to be highly covalent, right? That is going to be highly covalent. So if you talk about here, chlorine is same, lithium, right? This is beryllium and this is sodium, right? And this is chlorine. Where you have less electronegativity difference, where you can see less electronegativity difference, right? That will have the maximum covalent character. Very good, very good, very good. So answer is going to be third. Reason being, because here it is having, we know that here it is, if you see this here, this is beryllium, this is chlorine, this is having the less electronegativity difference. That is why this is, less is the electronegativity difference, more is the covalent character. So covalent character will be maximum here, right? Then you have lithium, then you have sodium, because we know that along the period and down the group, along the period electronegativity decreases, down the group electronegativity increases, right? Here electronegativity will decrease, here it will increase. That is why sodium has even more electronegativity, right? That is the reason sodium will have maximum electronegativity difference with chlorine. That is why it is highly ionic in nature and it is not a covalent compound, right? Okay. Now next is Next is which of the following pairs will form the most stable ionic bond? Again the question based on ionic bond. Now they are asking which of the following pairs will form most stable ionic bond. Now guys, most stable ionic bond. Now ionic bond means the electrostatic interactions. Again it is based on the charges electronegativity only. See, more is the charge, more will be the ionic character, right? Because more is the electrostatic interactions. Now here we know that it exists as positive, negative, positive. This is also existing in one positive, negative. This is two positive and this is negative, negative, this is positive. Charges is more. There is one compound where I can see there is M2 positive charge, right? So that is why which of the following will form most stable ionic bond? So most stable ionic bond will be MgF, because you're answering NaCl, right? Because ma'am, we have seen NaCl maximum times, right? Okay, but if you have Mg2 positive and F negative here, even the you have seen that, okay ma'am, what about the electronegativity difference also, right? Sodium, magnesium, this is sodium, this is magnesium and this is fluorine. If you talk about the electronegativity difference also, right, this is electronegativity decreases along the period. Here electronegativity will decrease. That means it has less electronegativity here, right? Okay, so based on this you can say that ma'am, magnesium has less electronegativity, hai na? Then ma'am, it should be more covalent, it should be more ionic, right? But see, this is with chlorine and this is with fluorine, and this is having two positive charge, this is having plus positive charge. That is the reason second is going to be the first answer. Okay, yes, 2 is going to be the first answer. Okay, formal charge you also have to see. Yes, if there were all the elements were having, all the options were having +1 plus -1 charge only, then we will see the electronegativity. But if there is charge difference, then we have to see the charge as well, right? Okay, next question is the weakest among the beta. All these are your previous year questions only, and you can easily see that they are not very difficult, right? There are questions easily that you can easily score good marks, right? There are also questions where you don't need that much conceptual knowledge, right? This is based on a very simple concept, right? Weakest among the following types of bonds. So such a simple question it is. Weakest among this. Ionic bond is the strongest. Usually students have this confusion that ma'am, covalent bond is stronger. No, ionic bond is stronger because there is electrostatic interactions. Then covalent, they are asking which of the following is weakest type. Weakest. Which of the following is a van der Waals interaction? Hydrogen bond is a type of van der Waals interaction. Yes, that is why D is going to be the weakest. Okay, D is the correct answer. D is going to be the weakest bond present here, right? Okay, yes. Okay, chalo. Now, next is strongest bond is in between. Okay, you have to see strongest bond. Strongest bond is between which of the following? Strongest bond. That means I need to see if you have CSF and NaCl, okay? CSF, right? And you have NaCl, right? Okay, if you talk about CSF, right, that means ionic bond we have to see. If you talk about CSF, right, okay, it is down the group over here. If you talk about the anion part here, it is fluorine, chlorine, bromine, iodine, right? For CS, you have F here, right? And for Na, you have Cl over here, right? Okay, so on this, you have to see the strongest bond here between these two, right? If you see the strongest bond here, there is high electronegativity difference over here, right? Okay, this is belonging to the same group only, that is why it is going to be having the same charge, plus plus minus minus, right? Okay, if you see the electronegativity difference is going to be more over here, right? Okay, as compared to this, right? This is a group number 17, this is group 1. So this is not having that much electronegativity difference as compared to these two. Electronegativity difference is very high, right? So that means it is going to have a very strong ionic bond, right? So that is why ionic bond is strong only. So answer is going to be first is the correct answer. Okay, got it? Yes, ionic strongest bond. So according to the Fajan's rule, beta, all these are based on Fajan's rule. Ionic character increases with increase in the size of cation, decreases in the size of anion. You can also write it over here. Very, very important point, right? Very, very important point, that ionic character is directly proportional to cation, inversely to anion. Okay, ionic character is directly proportional to cation and inversely to anion. This is, I am not talking about the charge, I am talking about the size here, right? CVS has high ionic character than NaCl, hence bond strength will be stronger. Okay, next is among the following, which compound will show highest lattice energy? Highest lattice energy, right? Which of the following will show highest lattice energy? KF, NAF, CSF, RBF. Okay, this is F is same. Okay, so this is going to be your group number 1, right? And fluorine is same. That means there is difference in the anion, right? Okay, difference in the cation, sorry, difference in the cation. If you talk about Na, right? Fluorine is over here, right? So Na, down the group we know that size is increasing. Size is increasing. Cationic size is increasing. That means ionic strength is increasing down the group. So CSF is going to have the strongest ionic strength, right? Okay. Ma'am, do this series also in JEE. After completing organic chemistry, you'll also do this in JEE, right? So CSF is going to have, wait a minute, wait a minute, they are asking which is also highest lattice energy. Okay. Now, guys, we know that if you talk about the ionic character here, or you can say ionic bond here, that will be, first you will have NAF, right? Then you have KF, then you will have RBF, then you will have CSF, right? That is going to be the ionic character. So ionic character will increase, right, as we go down, right, because that is directly proportional to the cation. So that will increase here. So CS will have the maximum. CS will have the maximum ionic character. Now they are asking you highest lattice energy required, right? Okay, so highest lattice energy, that will have the covalent character maximum, so it will be NAF, right? Is the highest lattice energy, the size of the cation are in this order, right? Okay, so you just have to see opposite of the ionic character, that is going to be the answer. right? Okay, this is also based on same Fajan's rule only. This is also based on Fajan's rule only. So different kind of questions are asked. Here they are asking you highest lattice energy. That means they are basically asking you the covalent character only, right? Here they are asking you the ionic character directly, right? Here also they were asking you the strongest bond. That means they were asking you the ionic character only. If you see this, like if you see this, like this question is same only. This is also same question. This is also same question. This is also same question. Okay, those were the same question only, but they are asked in a different manner. The question, the examples are same only. They are asking you the question in a different manner. Okay, this is what I tell you to analyze the previous year questions. Right now, arrange the following in increasing order of covalent character: NaCl, RbCl, MgCl2, AlCl3. Right, again the same question based on Fajan's rule, right? Okay, that's what I wanted to tell you, that how to analyze things, right? So this is your covalent character, guys. Covalent character, right? That will be, covalent will be directly proportional to anion and inversely proportional to cation size, right? This is, I'm talking about the cation size, right? If you talk about this NaBr, this is Na, this is Br, right? If you talk about Mg, right? Sodium, magnesium. This is magnesium, this is aluminium. It's like this, right? This is the placement of atoms here, right? Here we know that it is basically into the charge. This is 2 positive, this is 3 positive. So more is the charge if they are asking you the covalent character. Firstly, we know that if you talk about the charges, more is the charge, more is the size of, more is the ionic character, right? Okay, yes, okay, thank you, thank you. Now, firstly, though, you have to see the charge over here, then you have to also see the size in these two things. Here you will compare the size, in this you will compare the charge, okay? In this you will compare the charge, right? Okay, so everybody try to answer it. 4, 3, 1, 2. 4, 3, 1, 2. Which question you are saying is right? 4, 3, 1, 2. C, you are saying it is right, huh? Covalent character 1, 2. This is 1, 2. This is 3. This is 4. Okay. So this is having the highest ionic. If I say highest ionic, then the covalent will be basically Fajan's rule only. Na? It is having the highest ionic character. So covalent character will be minimum. They are asking you in the increasing order. If you talk about the size here, right? If you talk about the size here, wait a minute, I think P only. Arrange the following in increasing order. Wait a second. Let me just arrange it here. If you talk about the size here, firstly, Na and Rb, right? Same positive charge, same positive charge. So down the group size is increasing. That is why ionic character will decrease. Sorry, covalent character will decrease here. So covalent character, this is Rb, this is Na. So covalent character will be minimum in Rb, right? Because here, let me just firstly write it in the form of ionic character. For me, it is very difficult to write it in the covalent character because my mind is thinking about ionic only. Ionic is directly proportional to cation and inversely to anion, right? So here we know that if you talk about the ionic character here, then Rb is going to have the maximum, right? Okay, then you will have sodium. Out of sodium, magnesium and aluminium, you will have something, right? Okay, okay. So 1, 2, 3, 4. If you talk about the charge here, right, that will be Na, then you will have Mg, then you will have Al, right? This is going to be the ionic character, right? If you talk about the covalent character here, that is going to be the opposite. Rb, then Na, then Mg, then you have Al. So now this is basically Rb is 2, Rb is 2, then you have Na, that is 1, right? Then you have Mg, that is third, then you have Al, that is fourth, right? So answer is going to be 2, increasing order, na? 2, 1, 3, 4. 2, 1, 3, 4. Okay. So answer is going to be 2, 1, 3, 4. Covalent character, yes. Okay. So answer is going to be covalent character. So now let us see the like Fajan's rule definition here. Smaller size, greater charge on cation favors the formation of partial covalent character in the ionic bond. Okay. This is all what you have to remember. That if you want to see the covalent character, that will be directly proportional to the charge on cation, and that will be inversely proportional to the size of cation. Okay, size of cation. That is a direct relation. You can write it somewhere. If they ask you the ionic character, that is totally opposite. Okay, ionic is totally opposite. That is directly to size of cation, inversely to the size of anion, and inversely to the charge on cation as well. Right? Okay, so that is going to be the Fajan's rule. Right? So based on this kind of question also can be asked. Right? Okay. Now, next question is, which of the following is correct order of interactions? Correct order of interactions. So basically, this is a very simple like thing, right? Okay. If you talk about covalent, hydrogen bonding, van der Waals, dipole, they are asking the correct order of interactions. So strongest among them is definitely okay. Now guys, I am waiting for your answers in the comment section, right? Hydrogen bonding is also kind of van der Waals forces only, but hydrogen bonding is stronger than van der Waals forces, right? Okay. So dipole, when the dipoles are getting interacted with each other, right? Okay. Covalent, hydrogen bonding, then you have what and what? B, covalent dipole interactions, then you have hydrogen bonding and van der Waals forces. Do experimental chemistry. When you will do experimental chemistry I'll do after this series. Okay, I'll do experimental chemistry after this series. Salt analysis and all, we will do that, right? Chalo. Now here the answer is going to be B. That is, first is covalent, then you have dipole interactions, then you have hydrogen bonding, then you have van der Waals forces, right? Next question is, which of the following is not a correct statement? Right? You have to tell me which of the following is not a correct statement. The canonical structure have no real existence. Canonical means resonating structures, right? They don't have real existence. Every AB5 molecule does in fact have square pyramidal structure. Like they are saying all the AB5 molecule always will have square pyramidal structure only. Multiple bond are always shorter than corresponding single bond. The electron deficient molecules can act as Lewis acids, right? What do you think, which of the following is not a correct statement? They are asking you not a correct statement. So guys, as you can see here, they have asked you so many concepts, but all the concepts are very general. First concept, by the time you are answering me, I am telling you the concept on which they are asking you the question. First is they are asking you shapes and hybridization. This is a very, very important topic, right? Okay, this is a very, very important topic. Then they are asking you, this is a simple statement, right? This is also a very simple statement. This is also a general statement. All of them are general statement. Only one of them is your not a good statement, right? Only one of them needs, that is shape and hybridization, needs something like which you need to have knowledge about. Otherwise, so all of them are very simple statements, right? Okay, yes. Okay, okay, Sanya, no worries, beta. Just clear your NEET, है ना? Don't worry. चलो. Now, if you talk about AB5 kind of molecules, now two kind of geometries they will show you, है ना? What are these two kind of? Firstly, so let us know that which of the following is the wrong statement. This B is going to be the wrong statement. Reason is because EB5 molecules are going to show you two kind of geometries, right? So what is this and what is this kind of geometry? Square pyramidal. Square pyramidal is basically a kind of geometry where what you will have a square, right? And you will have one bond over it, right? Okay. So this is the square pyramidal geometry where you have a square and you have a pyramid over it. It is also having A, B5 kind of molecules. If you talk about the other geometry, it can also exist like this. It can also exist like this, where you have trigonal bipyramidal geometry. Okay? Yes. Now this is trigonal bipyramidal. This is the trigonal. This is two pyramids here. This is also AB5 kind of geometry. Now, both are AB5 kind of geometry. So, this statement will become itself wrong. So, in the question, topic name you can write there, shapes and hybridization. If you are thinking that, ma'am, I want to leave, like I don't want to do inorganic chemistry. One topic, short 1 to 2 questions are definitely will be there in your exam. That is shapes and hybridizations. Each and every shape, hybridization, beta, they should be on your tips. You can't afford to skip this topic. This is like most important topic of inorganic chemistry, right? Okay. Next is, which of the following molecules will form linear polymeric structure due to hydrogen bonding? Linear polymeric structure due to hydrogen. Linear, what do you mean by linear? Linear means at 180 degree to each other. So we know that this HCl, right? HCl, HF, HCl will not show hydrogen bonding. This will show, this will show, this will show, right? But here it will be a tetrahedral, it will not be linear, right? Here also the shape is not linear, right? This is not a linear shape. So which is a linear shape? HF is a linear shape, like HF is a linear shape. So answer will be D is the correct answer. HF form linear polymer structure due to hydrogen bonding, and this is intermolecular hydrogen bonding. One question, simple question can be asked on intermolecular and intramolecular. Okay, so I'll tell you intermolecular this kind of question, and based on intramolecular I also tell you what kind of question they can ask you. Right now here the question is PO4 3 negative ion, the formal charge on each oxygen atom and PO bond order respectively are. Now guys, first thing is you need to know what is this PO4 3 negative looks like. Right, for that I told you just a hit and trial method for chemical bonding you need to have. See, phosphorus belongs to group number 15. I am assuming that you don't know this structure and this structure is there in the exam. Then what you will do, right? You don't know this structure, then this structure appears in the exam, then by hit and trial method how you can understand this. Group number 15 means 5 valence electron. That means phosphorus will have 5 valence electrons, right? That means 5 bonds it can form, right? Now you have 4 oxygens. 3 oxygens will be O negative because you have 3 negative charge that will come from one oxygen, and 1 will be a double bond. So you can just write it here, 1 will be a double bond, other will be O negative, O negative, O negative. So this will become the structure of PO4 negative. We know that why I have drawn it in tetrahedral geometry, because I know that this will form 4 sigma bonds, right? 4 sigma bonds means this will be, phosphorus will be sp3 hybridized, right? Now, why I am telling you all the things, because if they have asked you PO4 3 negative here, they can also ask you hybridization of PO4, the shape of PO4 3 negative, anything they can ask you. But here they have asked you that what is the formal charge on each oxygen atom. So formal charge is going to be, what is the total charge that you have here is -3, right? And how many atoms are distributing that charge? That is 4. So this is going to be your formal charge, that is minus 3/4, that is going to be minus 7.5 is going to be that, right? So this will be eliminated. Okay, what about PO bond order? If you talk about the PO bond order of PO. If you talk about the bond order, it is forming how many bonds? 1, 2, 3, 4. 4 bonds it is forming. 4 sigma bonds it is forming, right? So it is going to be, wait a minute, number of bonds, that is sigma plus pi, and this is going to be the number of resonating structures it is going to form, right? Okay, so this is not related to MOT. Here bond order is not solved on the basis of MOT, not MOT. Here it will not be solved on MOT. MOT basically we solve it for NO, CO, CN, these kind of molecules, right? This will get really complicated, right? That is not in your syllabus to solve the bond order by this method, by that method MOT, right? So here what you will do, resonating structures, we know that electrons will jump here, it will jump here. Here also electron can jump here, it can jump here. Electrons can jump here, it can jump here. So basically you will have 4 resonating structures that can be formed. Okay, and that is the reason it is 5/4, that is 1.25. So C is going to be the correct answer. Okay, understood? Chal. Next question is going to be the boiling point. Again, this is on hydrogen bonding. So boiling point of para-nitrophenol higher than that of orthonitrophenol. If you talk about para-nitrophenol and orthonitrophenol, this they can also ask you steam volatility. Steam volatile. Because previously they have asked you this question based on which of the following has high boiling point. Now they can ask you in a twisted manner, that is which of the following is steam volatile, right? Now for that, this is the thing that when you talk about, you have OH here, NO2 here, ortho, it will have hydrogen bonding. But if you talk about para, it will not have a hydrogen bonding. That means intramolecular hydrogen bonding is present in orthonitrophenol. That is why the boiling point of this is going to be low, because it is forming hydrogen bond within the molecule, not with the other molecule, right? So other molecules, it will have van der Waals interactions. That is why boiling point will be low for ortho, right? Ortho will have low boiling point as compared to para. That is why ortho is steam volatile. Ortho is steam volatile. And here now you can see this NO2 group at para position behave in a different way than at ortho, right? Okay. Intermolecular, this is definitely not true. Intramolecular hydrogen bonding exists in this, no. There is intermolecular hydrogen bonding in para. Para-nitrophenol has higher molecule, this is also not true. There is intermolecular hydrogen bonding in para, that statement is true, because in para you will have intermolecular hydrogen bonding. That means hydrogen bonding with the other molecule of para-nitro, not within the molecule it will have, right? So answer is going to be C. Next is students, we have which of the following, now they are saying which of the following formula does not correctly represent bonding capacities of 2 atoms. Okay. Bonding capacities of 2 atoms. That means which of the following is incorrect formula, or you can say incorrect structure. That means octet is overly complete, octet is not complete, something like that, right? So here you can see phosphorus is having, it should have 5 bonds, but it is having 4 bonds. That is why we have put a positive over there, right? If you talk about nitrogen, nitrogen is supposed to make 3 bonds, but here it is forming 4 bonds, but here the 4th bond is the coordinate bond. So this is also possible. Here oxygen is supposed to make 2 bonds, it is making 2 bonds only, so that is why there is no charge here. Carbon here, as you can see, this is a double bond, guys. Okay, here carbon is forming 3 bonds. Here carbon is forming 1, 2, 3, 4, 5 bonds, and there is no charge on the carbon, right? That is why this is going to be the incorrect answer. Okay, right? Okay. Welcome, Madan, Gula, welcome Ita, welcome to the class. Okay. Next question is, which of the following set of molecule will have zero dipole moment? Now, beta, write the next topic. Beta, are you writing the topics in some sheet or somewhere? Right? Okay, somewhere are you writing the topics also? Next topic is dipole moment. This is also, I would say, make two categories. One is time consuming and priority. One is not that much time consuming, but they can be asked at a easy format, right? Easy questions will be asked. And easy question categories, first is hydrogen bonding, then you have Fajan's rule, then you have dipole moment. These are three simple short topics from where the question and very simple questions will be asked, right? So these, like this, so you can like 100% be sure that you are right about that question, right? Shapes and hybridization will definitely take time. You need to have concept clarity, but from there even 2 to 3 questions you can see, right? Okay. Now, which of the following set of molecules will have zero dipole moment? Now they are talking about boron trifluoride, hydrogen fluoride, BF3, then you have HF, here you have CO2, here you have 2,3-dichlorobenzene. 2,3 means 2, 1, 2, 3. This will also not have zero. Okay, nitrogen trifluoride, NF3. This will definitely not have a zero dipole moment. It has a lone pair. So we don't need to see the other things. Boron trifluoride, beryllium difluoride, okay. Carbon dioxide, 1,4-dichlorobenzene. That means 1 and 4. This is the possibility, right? Ammonia, again, beryllium tribe, water, definitely not. So this will also is eliminated, right? So as you can see, this particular section, dipole moment, I'll tell you how to do this. If I ask you, what is BF3? This is BF3. This exists in trigonal planar shape. That is why what will happen here, dipole moment is always from positive to negative. This is less electronegative to more electronegative, less to more, less to more. Here what will happen, you will have a resultant that will cancel out this and you will have a net dipole moment 0. If you talk about BEF2, beryllium difluoride, that is existing as a linear molecule. It is having sp2 hybridization. That is why from positive to negative, it will directly cancel each other. Similarly with carbon dioxide, it is double bond here. Again, it is going to cancel it. Beta, sp2 hybridization means it is going to have a linear geometry. Linear geometry to always will cancel each other if you have the same molecules, same atoms on the sides. 1,4-dichlorobenzene is this. 1,4-dichlorobenzene is this thing, right? This is your benzene, this is chlorine, this is chlorine. So what will happen here? This will cancel each other and your net dipole moment is going to be 0. So answer is going to be C is the correct answer, okay? C is going to be the correct answer, right? Okay, yes. Okay, now next is, which of the following is correct order of dipole? Again, a very simple question is asking, they are asking based on dipole moment, okay? Based on dipole moment, again one simple question they are asking, that is H2O, NF3, NH3, BF3. These are the 4 molecules that will have. We have to see which of the following has the highest dipole moment. So first thing is, guys, you need to see BF3, right? BF3, if you talk about BF3 is like this. If you talk about NH3, this is N, this is H, this is H, this is having a tetrahedral geometry, one lone pair over here, right? Okay, what about NF3? This is F, this is another F, this is F, and one lone pair over here, right? Okay, what about this water? Water is having oxygen. It is again having tetrahedral geometry, but 2 lone pairs over here, right? Now, you need to see which of the following will have the highest dipole moment, right? So if you can see here, always it is from, if you first need to check between NH3 and NF3. This is the most asked question of NEET, right? NH3 and NF3. Now, here what you need to remember that it is always from positive to negative, positive to negative, positive to negative. And always when you have lone pair, it will be from atom to lone pair. This is from positive to negative. Fluorine is more electronegative as compared to nitrogen. Positive to negative, again positive to negative, right? Okay, what about this one? This is positive to negative, positive to negative, positive to negative. This is positive to negative, positive to negative. This is lone pair to atom, lone pair to atom. Now, can you see one thing? That in case of BF3, it is having zero dipole moment. It is cancelling it throughout, right? It is cancelling it. So BF3 is going to be the minimum. It is going to be the minimum. So this is ruled out, this is ruled out. You have these two options, right? Okay, I'll tell you how to solve the questions, okay? Now, you have NF3 and NH3, you have NH3 and NF3, right? Because I don't have proper values here. But can I see that, can I say one thing here, that over here there is no cancellation, everything is getting added. Over here also there is no cancellation, everything is getting added here, right? Okay, but if you see this thing here, if you see this thing, oxygen, nitrogen, yes, okay, nitrogen, oxygen. If you see here, you have more electronegativity difference. This more electronegativity difference means OH is going to have more dipole, because oxygen is, if you talk about OH and NH, definitely OH is going to have more, right? Now, this is another thing. Now, let us firstly compare NF3 and NH3. If you compare NF3 and NH3, you can see here you see no cancellation, but here it is being cancelled. That means now some students say that NF3 is having 0, ma'am, because it is getting cancelled. Array, the resultant is definitely going to be this, but the resultant is going to be not 0, right? So it will not entirely cancel the lone pair here. Here you have BF, BF and BF. That is why it was entirely cancelling out each other. Here if you have NF over here, then it will cancel. But here you don't have NF. Right, this is the lone pair, so it will not entirely cancel. It will not be equals to 0. It will be more than 0. So here, definitely we can say that NF3 has less dipole moment as compared to NH3. So this is also ruled out. Answer will be C. Now, ma'am, how you tell whether, how you are saying that NH3 out of NH3 and H2O, NH3 is having less dipole moment as compared to water? Because as I told you, O and H has more electronegativity difference. More is the electronegativity difference, more is the dipole, right? So that is the reason it is having more dipole moment as compared to this. So answer will be C is the correct answer, okay? Got it? Got it guys? Maybe cancel some cases. Which of the following is a polar molecule? Which of the following is a polar molecule? If you talk about the polarity of the molecule, polar molecule, again based on dipole moment only, see, you have to know the shapes, right? If you talk about the shape of, firstly let us talk about the shape of SF4. Now I'll tell you, to all those students who don't know the shapes, I'll tell you how to, if you don't know the shape, then how to draw the shapes, okay? So remember that sulfur belongs to group number 16, right? So group number 16 means it is going to have 6 outermost electron. That means 6 bonds it should form. But actually with fluorine, so it can form only 4 bonds. So I'm just simply drawing it like this, right? That means it will have 4 bonds. That means just replace the 4 electrons here. That means out of 6 valence electron, it has used 4 electrons in the bond formation. That means 2 electrons you are left with. That means 1 lone pair you will have here. That means in SF4, what you will have? In SF4, you will have 1 lone pair over here, right? 1 lone pair will be formed over here, right? Okay, so basically can we say that it will have in total 4 bond pair plus 1 lone pair, total the answer will be 5. So it is going to form, guys, total answer will be 5. That means whenever you have 5, that is going to make trigonal bipyramidal geometry. Once you know the geometry, you can easily draw the structure here. So structure will be S1, 2, 3, 4. This is going to be the bipyramidal geometry and 1 lone pair. Why I have placed lone pair on the equatorial positions? Because to make more stability, lone pair is usually placed on the equatorial positions only, right? So that is why we will say that this is definitely, if you talk about the polarity here, this is definitely a polar molecule only, right? This is definitely a polar molecule because it is not getting cancelled, right? All the lone pairs, all the dipoles are not getting cancelled here, right? So basically it's like this, okay? It's like this. It's like this. Wait a minute. Let's assume that white ones are your, let's assume that these white ones are your fluorine atoms. This is the lone pair. Okay, so this is making a seesaw geometry, a seesaw shape. Now here, why the lone pairs are not getting cancelled? Because if you talk about the trigonal plane here, trigonal plane, if you talk about only the trigonal plane, we know that it is not getting cancelled. Definitely, this SF is getting cancelled with this SF, but this SF and this SF and this lone pair, they are not getting entirely cancelled with each other. So this is going to be a non-polar molecule. This is going to be a polar molecule which will have mu not equals to 0, right? So answer will be first. Okay, what about the other shapes? If you talk about the shape of SiF4, now students, we know that silicon belongs to group number 14. 14 means it will have 4 electrons here, 4 bonds it is forming, that means 0 lone pairs it will have. So it will have Si, it will have tetrahedral geometry which is having 4 lone pair plus bond pair, right? Definitely the geometry, the dipole moment is going to be 0 here. Okay, if you talk about XeF4, BF3 though we already studied that mu is equals to 0. What about XeF4? How to tell the shape of XeF4? Simple, same way. This belongs to noble gases. Noble gases has, what is the valence electrons of noble gases, guys? This is having 18, so that means 8 electrons. It is forming only 4 bond pairs, that means 4 electrons you are left with. That means 2 lone pairs will be formed. So in total we know that 4 bond pair plus 2 lone pair, it is going to have 6. 6 belongs to octahedral geometry, so it is going to be XeF4, right? And 2 lone pairs over here, right? Okay, so that is why definitely they will cancel, this will cancel, this will cancel this will cancel this, and lone pairs will cancel each other. Then again mu is going to be 0. So this was a very, very important question. Okay, it was a very, very important question. Okay guys, understood? Okay beta, understood or not everybody? Are you able to understand the geometries here? See, when we started the class, there were so many students. Now the students have gone. Can you see your competition? The competition is not very high because most of the students are not even interested in studying. That's why don't worry about the competition. Right? Now, next is, even if someone leaks the paper, then also they will go. Next is the correct order of OO bond length in O2, in H2O2 and O3 is OO bond length. If you talk about oxygen bond length, guys, very simple thing, right? We are going to do here. If you talk about O2, we know that it has a complete double bond, right? If you talk about H2O2, it is going to be HOH. This is the structure. If you talk about oxygen here, it is going to be like this kind of structure where you have this is double bond, this is less means it is negative, this is going to have positive over here, this kind of structure. That means a resonance will exist here. That means a resonance will exist here. It will have this kind of structure, guys. Okay, partial double bond. Now, double bond length is definitely shorter, right, as compared to single bond. So single bond length is greater. Single bond is present in H2O2. So they are asking the correct order of, that means H2O2 will have the maximum bond length, right? Then you will have O3 because this has partial double bond. Then you will have O2 because O2 has complete double bond. That is why the bond length will be even shorter. So answer is going to be D is the correct answer. Okay. Next is the structure of ClF3. Now they are asking you the structure of, right? Okay. Chalo. Now, in the structure of ClF3, the number of lone pair of electrons on central atom Cl. So if you talk about the, okay. So do you want me to increase the speed of the lecture, guys? Do you want me to increase the speed of the lecture? If you want that, then I'll also increase that. Okay. I was slow because I thought that, okay, I need to explain. If you think that, okay, ma'am, please a little bit fast, then I'll be fast. Okay. Chalo. The structure of ClF3, the number of lone pairs. Now, beta, how you will tell the lone pairs? Same way, okay. So, you have Cl over here. It belongs to 17 groups, so 17 valence electron. It is forming 3 electrons, 3 bonds with F3, right? So, that is why 3 electrons will be eliminated. So, it will be 4 electrons here. That means 2 lone pairs will be formed, right? That means here you will have in total, you will have 3 bond pairs plus 2 lone pairs. So answer is going to be 5. So answer is going to be 5. So 5 means you will have trigonal bipyramidal. Trigonal bipyramidal means you will have this 1, 2, 3, 4, 5. Now you have to attach 2 lone pairs here. Lone pairs will be attached on this particular position, right? Okay, and this will be your F, F and F. So basically it is going to be a T shape. It is going to be a T shape, or you can say bent T shape, right? Okay, because of this lone pair repulsion, it will be slightly bent towards this side, right? Okay, now they are asking you the number of lone pairs. Number of lone pairs is going to be 2 here. Okay, lone pairs are going to be 2 here. Okay, understood? Yes. Chal. Now, next is which of the following molecule represent the order of hybridization? This is a very, very simple concept, a basic concept. I will not even give you any topic for this. And if you understand chemistry well, then you have to know this answer as well. But yes, if you say that here lone pair plus sigma bond, if that is 2, it is sp hybridization. If that is 3, it is sp2 hybridization. If that is 4, it is sp3 hybridization. So here, if you want to write it down here, okay, sp2, sp3, sp, sp, sp2, sp2, sp2. This is having 1, 2, 3 sigma bonds. So this is definitely here. Why I can't see a bond over here, right? I don't know. There should be a bond over here. So this is CH. It should be a triple bond over here. Hai na? It should be a triple bond over here. Yeah. So it should be a CH. It should be a triple bond over here. Right? Okay. Now we can tell the answer. Right? Now here we know that first is 1, 2, 3 sigma bonds. This is sp2 hybridized. Here definitely not sp2. Here also sp2 not. Here you have sp2. Second you need to get is sp3 hybridized. Here also it will be sp2 hybridized. Right? Second carbon should be sp3 hybridized. That means 1, 2, 3. sp3, wait a minute. sp2, which of the following molecules represent the order of hybridization? sp2, sp3, sp from left to right. sp2, sp3. Don't you think the question is wrong? sp2, if this is 1, 2, 3 sigma bonds, this is also 1, 2, 3 sigma bonds. This will also be sp2. This is 1, 2, 3 sigma bonds. It will also be sp2. This is also 1, 2, 3 sigma bonds. It will also be sp2. What about this one? This is sp3. This is 1, 2, 3 sigma bonds. It is sp2. It is sp2. This is sp3. I to can't even see a single structure like that. Right? Okay. Don't know how they have drawn it like this. Question is wrong. Question is wrong. Because following molecule represent the order of hybridization is not this. Here also it is sp2, sp2, sp and then sp. The question that they have marked wrong. So answer is from left to right. Here also it is not sp, sp, sp2, sp2. So the question is wrong. Okay. Yes. So answer, just eliminate this. The question is wrong. Okay. Question is wrong. Right. Now, next is the species having bond angle 120 degree. That means they are asking you sp2 hybridization. They are asking you trigonal planar species. Trigonal planar species. Now you have to answer the trigonal planar species here. So this is ClF3 trigonal planar. sp2, we know that if it is having 3, 4, 5, 6, 7, 2 more lone pairs, it will have. So it means that sp2 means total it should have 1, 2, 3 lone pair plus bond pair. This is also having 1 lone pair. This is also not possible. This is not having any lone pair. This is also having 1 lone pair. This is also not possible. For BCl3, it is the correct answer because you don't have any lone pair. So the hybridization will become sigma, sigma, sigma 3 is equals to sp2. That is trigonal planar. Answer is going to be 3 is the correct answer. Okay. Yes. Okay, yaar. What to do, yaar? It's our earth, but it's also their earth, no? So they have every right to bark. You can't stop them, right? They have every right to live their life, right? Now, which of the following structure is most stable? Wait a minute. Okay. Which of the following structure is most stable? Now, guys, always remember this is based on the concept that lone pairs on equatorial positions. Equatorial positions. So these are all under hybridization and shape only. So equatorial position it should have. This is the equatorial position. This is not the equatorial position. This is also one equatorial, one axial. So first is going to be the maximum stable. So answer will be first is the correct answer. Among the following molecule, you have these 4 molecules. We have already seen this, right? Which of the following shape does not describe any of the molecule mentioned, right? So you have to tell the shapes of all of them. SO2 molecule, it will exist like this. Sulfur, right? Sulfur, right? It belongs to oxygen family, which is having basically 6 electrons, right? 2 bonds it is already forming, so it will be 4 electrons will be left. That means 2 lone pairs it will have. But oxygen always form double bond here. So this will be sulfur, double bond oxygen, double bond oxygen. And here you will be left with 1 lone pair, right? That is the reason here you will have sigma, sigma and 1 lone pair, sp2 hybridization. So trigonal planar to it is representing, right? And here it is bent V shape. The shape is bent V. The shape is bent V. So this is having bent V shape is of SO2 molecule. Okay, what about SF4 molecule? What about SF4, guys? What about SF4 molecule? What about SF4 molecule? If you talk about SF4 molecule, again this belongs to sulfur. It should have 6 electrons, 4 electrons already gone, 2 electrons. With the fluorine, it is forming single bond. So it will be sulfur. It is having 2 electrons here. That means 1 lone pair it is having. Right, that means 4 bond pair plus 1 lone pair, it will have 5. That means trigonal pyramidal. So answer will be lone pair over here, 1. Seesaw shape it will have. Seesaw shape it will have. So seesaw shape is of SF4. Right. So this also not the correct answer. If you talk about ClF3, right? If you talk about ClF3, can you tell me the answer for ClF3? ClF3 beta, we have already done ClF3. ClF3 was like this. You have 2 lone pairs, you have 3 fluorines, right? 2 lone pairs over here. We have just done this particular shape, right? So this is having T shape. So ClF3, it is having T shape, right? Okay. What about the next one? Next is BRF5, right? Again, the same thing you will do. Beta, firstly for XCF4, we know that we have already done the shape here, XCF4. That's what I told you, that the same kind of molecules are repeated, okay? The same kind of molecules are repeated again and again and again. This is having which kind of shape? Square shape, right? So definitely it is having square shape, so that is not present here, but it is definitely not trigonal bipyramidal. Answer to we know already, the answer is bipyramidal, but still I'll tell you the shape of BRF3 also, right? What is the shape of BRF3? If you have to calculate it over here, BRF3 or 5, it is BRF5. Last time I am telling how to calculate the shapes, guys. Those students who are not able to understand, this is the time where you should know the way to calculate the shapes, okay? Central atom is bromine. Bromine belongs to halogens, that is group number 17. So 7 electrons it will have. It is already forming 5 bonds. So 5 electrons will be eliminated. It will be 2 electrons. This will tell us the lone pair. We know that with the fluorine it is making single bond, so we don't have to worry about that, right? Now we know that lone pairs plus bond pair is going to be 1 lone pair plus 5 bond pair. It is going to be 6. 6 belongs to octahedral geometry. Octahedral geometry means you have BR 1, 2, 3, 4, 5, 6. Out of this, 1 will have the lone pair. So I take this as the lone pair. Others are F, 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 F. Here it is square pyramidal. Square pyramidal. Okay, square pyramidal. So it's not like they will ask you the exactly same question. They can ask you what is the geometry of BRF5. You will say, ma'am, you told everything will be there. But ma'am, you didn't told us that BRF5 they can ask us the geometry. Beta, this is in the previous year question only, na? So they can ask you this, right? So trigonal bipyramidal, I can't see any geometry which was trigonal bipyramidal. So answer will be B is the correct answer, right? Okay. Next is which of the following pair both species have sp3 hybridization? sp3 means 4 lone pair plus bond pair. Okay, if you talk about this, definitely it is trigonal planar, right? If you talk about BeH2, definitely not. If you talk about NF3, yes, it is sp3. H2 is also sp3. So answer will be this. BF3 is not. So answer will be NF3, that means N lone pair, F1, 2 and 3. And oxygen also, you have 2 lone pairs here. So lone pair plus bond pair is your 4. Okay. So answer will be C is the correct answer. Okay. Yes, everybody try to answer this. Yes, I'll definitely do that as well. When the time is right, I'll also do that. Right. Now, next is which of the following pairs. Next topic, you can write it over there on your list. Next topic is isostructural and isoelectronic. Not isostructural, isostructural and isoelectronic species. Right. From there also the questions are asked. Right. Now, which of the following pair is isostructure? That means the same shape and hybridization. See, BCl3 and BrCl3, definitely not, because it will have 2 lone pairs here. Hybridization will not be this, right? Okay, NH3 and NO3 negative. This is BF3, NH4 positive and BF4 negative, right? Okay, so definitely this is not the correct answer. The option that we are left with is NH3 and NH4 positive and BF4 negative, right? Okay. So if you talk about NO3 negative, if you talk about NO3 negative, 2 double bond, NO3 negative, now O negative, right? Okay. So this will not we need to have sp3 hybridization. Here also we need to have, wait a minute, here we will have NH4, BF4, BF3. I think the answer will be D, है ना? Yes. Okay. So guys, if you talk about this particular statement, here NO3 negative, here nitrogen is not having the sp3 hybridization, right? If you see that it is forming one O negative bond, right, other are double bonds, then it is not having sp3 hybridization, right? So this is, we need sp3 hybridization here. But if you talk about BF4 negative and NH4 positive, to this NH3, when you take one more electron, one more bond it is forming, it will be 4 bonds. Here also boron is forming one extra bond, that is why boron is having one negative here. That is why boron will have sp3, so answer will be D is the correct answer, okay? Now, next is the shape and structure of XeF5 negative and XeO3F2 respectively are. XeF5 negative, right, and XeO3F2 respectively are. Very nice question it is, right? Okay, very good question it is. I'll tell you the reason. Reason is XeF5 negative has a very good, like very interesting shape. Here you need to follow the same thing that I told you. Xe has, it belongs to group number 18. 18 means 8 electrons. 5 electrons it is already making the bond. So answer will be 3 electrons. 6, 7, 8. 3 electrons will be left here. Right? Now, what you will observe here, 5 electrons are already making the bond here. That is the reason there will be 1 electron over there. So this is Xc, right? It will have 1 negative. That means 1 negative when we add that. 1 negative when we add. When negative when I am adding, it will have 4 electrons. That means in total 2 lone pairs will be there, right? Now if you talk about bond pair plus lone pairs, bond pair plus lone pair, that is going to be 5 plus 2, that is 7. That is why it is forming pentagonal bipyramidal geometry. Pentagonal means 1, 2, right? If you talk about this thing here, this is Xc, this is 1, 2, 3, 4, 5. Okay, so this is your pentagonal, right? Then this is in one plane only, this is in one plane only. Then you will have 2 lone pairs above and below. That is why it is pentagonal planar, because we have lone pairs here, right? That is why it is going to be pentagonal planar geometry, right? Pentagonal planar. So that is also, if you know this thing, then your answer is already solved. So answer is A. Next is XeO3F2. XeO3F2 to very simple geometry. This is the most of you know only, right? Xc, it is making double bond here. 2 fluorine atom, double bond, double bond, double bond, right? Okay, 2 fluorine atoms. So this is definitely trigonal bipyramidal geometry. So answer will be trigonal bipyramidal, and this, so answer will be A is the correct answer. Okay? Understood? What is the doubt, beta? What is the doubt? Okay. Okay, beta, understood what kind of question they are asking you again and again. Now that was based on shapes and hybridization. Next concept, it is based on MOT. Or based on MOT, what kind of question they ask you? Right? Okay, beta. Let's see what kind of question they ask you based on MOT. According to the molecular orbital theory, which of the following statement about the magnetic character and bond order regarding O2 positive is true? O2, that means it is having 8 plus 8, that is 16 electrons. O2 negative, it is having 8, 16 plus 1, that is 17 electrons. So it will use 1, 2, 2, 1 kind of situation, right? So when we are doing the electronic configuration, right? So you have to tell whether it's diamagnetic, paramagnetic, what kind of thing. So 17 will be, 8 will be abstracted because 8 is your kk dash. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, that will have 8 electrons. So that is why 8 electron I have already taken out. So it will be minus 8, it will be 9 electrons. So 9 electrons I have to fill in 1, 2, 2, 1. Okay, 1, 2, 2, 1. 9 electrons I have to fill. 1, 2, 3, 4, 5, 5, 6, 7, 8, and this is 9th. Definitely it is having one unpaired electron. So this is paramagnetic, right? And what about the bond order? What about the bond order? Bond order is bonding minus anti-bonding. This is anti-bonding, this is also anti-bonding. Bonding is 1, 2, 3, 4, 5, 6 minus 3 by 2. 3 by 2, it is 1.5. Okay. If you talk about the bond order of oxygen, that is 2. Bond order of oxygen is 2. It is making 2 bonds. Now, if you want to calculate that also, in oxygen, we have how many electrons? 8 electrons. That means total you have 16 minus 8. That means 8 electrons, and that you have to fill it like this. So here it will be 1, 2, 3, 4, 5, 6, 7, 8. 2 paramagnetic. This is anti, this is anti. Bond order will be, this is 1, 2, 3, 4, 5, 6 minus 2 by 2, that is 4 by 2, that will come out to be 2, right? So definitely it is less than O2. So answer will be A is the correct answer. Bond order is greater than O2. Wait a minute. How come bond order is greater than O2? 3 by 2, na it is. How? Oops. But I am so sorry. I calculated for O2 negative. We have to calculate for O2 positive. Acha. theek hai. No issues. For O2 positive, what we will do? We will lose 1 electron. 1 electron will be lost here. That means it will be 15 here. If it is 15, that means out of 17, you subtract 15. Beta, are you able to understand this? Is a simple trick that I told you. 15 minus 8 is equals to what? 8 electrons you are taking out of 15. So it is 8 electrons here. Right? Not 8. It is actually 15. That is 7 electrons here. So it will be 7 electrons will be 1, 2, 3, 4, 5, 6, and this is 7. Right? Then the bond order will become 6 minus 1. 6 minus 1, that is 5 by 2, that is 2.5. For O2 positive, it is greater than O2. So answer will be B. Okay. For O2 negative, you can also write it here that for O2 negative, this is the correct answer. And for O2 positive, this is the correct answer. Okay. Got it, everybody? But you are talking in some other language that I am not able to understand. Then how come you feel that I'll be able to teach here? Huh? Are you even interested in learning something or not? Or no, ma'am, only Roshni I feel is interested. If the other students are not interested, then why even I am doing so much hard work for you guys? I should also not do, na? I should also take a chill pill, just like you are chilling here. Right? Then it's not, I am not going to become a doctor. Right? So, why I am doing all this? Just for you, to make your dream come true. Right? And what I see in the comment section is this. Huh? What is it? What it is written here? Vedantu NEET English. Right? So, if you want to chit chat, you can talk in English. Right? Achha. Next is, why I always have to come here and you have to spoil my mood by this, huh? Why this is like a daily routine, huh? This is daily routine. I always come, I'm in a very happy mood. I come here and then my mood gets ruined. Like so much hard work for this thing, huh? Very good, Chetu, very good. the correct order of ionic radii, O2 negative, this and this. Now guys, again write one more topic here. So much hard work for you guys, and this is what sometimes I feel I don't deserve this, right? Now write it down somewhere that this is isoelectronic species. Isoelectronic species. Isoelectronic species. So 3-4 topics I have told you till now. This is isoelectronic species. Okay, so in isoelectronic species, they will ask you the size basically, which of the following will have the order of size, and this they will ask you, right? So the correct order of ionic radii they are asking you. Yes, very good, right? Okay, yes. Very good, Arushi. I am so proud of you, beta. I am so proud of you, right? Arushi, who is paying for your fees, beta? Who is paying for your fees? Hanji beta, Arushi, who is paying for your fees? You yourself. I think you must be earning, right? Okay, chalo. Arushi, do one thing. Arushi beta, do one thing. Okay, just go and watch some movies. है ना? Pushpa 2 is having a lot of views, beta. You watch it, right? Lakhs and lakhs of views. Tell me if that is going to give you your NEET seat. No, right? Okay. Beta Arushi, you have already told what you have, like what's your mindset. Now you don't need to write anything and you can leave from this particular live session. You can go, right? Now, the correct order of ionic radii is O2 negative, N3 negative, F negative, Mg2 positive, Na positive, Al3 positive. If you see the electrons here, these are basically isoelectronic species. Just like oxygen has how many electrons? Oxygen has basically how many electrons? It has 8 electrons plus 2, that is 10. Right? So here I am going to write all the electrons. This is having 10 electrons, 7 plus 3 is 10, 9 plus 1 is 10, 12 minus 2 is 10, sodium is 11 minus 1 is 10, right? Aluminium is 13 minus 3 is also 10. Now they are asking you the size here. Now they are asking you the size, right? Yes. Haan beta, I am to ignoring them. That's why I am standing. That's why still I am teaching you guys. If I would have taken them seriously, I would have gone 1 year back only, right? Okay. Nah, they are not serious. They are not even NEET aspirants. They are the reason we have 23, 24 lakh students appearing, because half of them are not serious just like them, right? Now, these are all the isoelectronic species, right? Okay. In isoelectronic species, you need to remember one thing. The size will be directly proportional to the charge on anion, and it is inversely proportional to the charge on cation. Right? This is the important rule. From here only you will get the answer, right? So more is the charge on an ion, more is the size. Reason being, more electrons are getting added here, so size is increasing. When you are taking out the electron, for example, you had this proton, 3 proton here, you had just 1 electron over here, definitely it is going to attract it and size is going to get decreased, right? So answer will be A is the correct answer, right? Answer will be A is the correct answer. Next question is from DNF block. This is from P block, right? Okay, chalo. Now guys, we have already also completed chemical bonding here, right? From chemical bonding, can anybody tell me what are the important topics, right? I told you 5-6 important topics, right? I'll just gonna write it here, right? Analysis of chemical bonding, analysis of chemical bonding. What are the important topics? Anybody in the comment section? I'm also gonna tell you each and every single thing here. First is, if you talk about, first is very simple topic, that is Fajan's rule. Second is dipole moment, right? Dipole moment. These are less time consuming. Little bit of hydrogen bonding also, simple questions are based on this, right? Then fourth is your isoelectronic species. Isoelectronic. From here, standard questions are asked. Here also based on the size. Here also based on the size of ionic radii. Here based on the hydrogen bonding interactions. And here based on the polar non-polar molecule. These 4 topics are asked. Then major topic is your shapes and hybridization. Shapes and hybridization. Right? Okay. And then you have MOT. Right? Molecular orbital theory, where questions are mostly based on bond order, right? Bond order or magnetic property, right? So these are the important topics of chemical bonding which you need to do, from where the questions will be asked. Okay, I can guarantee that if you do these topics, then you will master the chemical bonding, and this is a very, very important chapter, right? Okay, yes. Now, let us start with this one, outermost electrons. Then the question is outermost electron configuration. Now, students, we are in P block now, most of them will be exceptions only, right? So, we will pick up the speed here, okay? Right? Okay? Chalo. Vakanda, beta, I have already told you that, but in inorganic chemistry, the exceptions, then chemical bonding, coordination chemistry. These 3 are the most important topics in inorganic chemistry, right? Okay. Outermost electronic configuration group 13 element E is 4s2 4p1. The electronic configuration of an element of P block having having period 5 placed diagonally to the element E is. Okay, they are saying there is some element E which is having 4s2 4p1, right? That means it belongs to the 4th period. Now you need to tell us, to this E element in the 5th period, what thing is placed diagonally over here. So for that, you need to check the period here. So this is, if you talk about the 4th period, Bal Gaye, right? This is, you have gallium over here, and which is diagonal to it, that is tin is diagonally present to it, right? So answer will be, for tin we have 4d10 5s2 5p2. So answer will be D is the correct answer, right? Okay, these kind of questions they ask you. The correct order of electron gain enthalpy. Electron gain enthalpy, guys. Electron gain enthalpy. Everybody in the comment section, what is the correct order of electron gain enthalpy? Right? This is very, very important, right? Very, very important. All of them you will see are the exceptions. In electron gain enthalpy, we know that down the group, size is increasing, so electron gain enthalpy should decrease, right? Okay, but what will happen here? What will happen here? This is usse tepo, right? So it should be oxygen. It is decreasing down the group. Sulfur, then this. Okay, it should be like this. But in reality, the oxygen will jump here, and because of the small size of oxygen, it will be in the end. So answer will be A is the correct answer. Wait a minute. So answer will be A is the correct answer. Okay, A will become the correct answer. Okay, okay, chalo. Now A will become the correct answer. Very, very important. Next is, in general, the property magnitudes only that shows opposite trend comparison. Beta, now I am giving you direct questions. Here to not even ki they will do if and but, they will mold the question. Nothing they can mold here. Exception will stay as it is only, right? So direct questions, that ditto copy paste they will ask you in the exam, right? In general, the property that shows opposite trend in comparison to the properties across the period. See, across the period you talk about this. In comparison to the opposite trend in comparison to other properties, right? If you talk about the atomic radius, it is always like opposite of the others, right? Wait a minute. Atomic radius size is decreasing along the period. Electron negativity is increasing. Electron gain enthalpy is increasing. Ionization enthalpy is increasing. So atomic radius is the one which is always showing the opposite trend here, right? Next is the atomic number of uninil, unnil, neum. Unanilinium, guys. This is based on IUPAC naming, right? Okay. Based on IUPAC naming, a simple question is asked, right? Unanilinium. Okay. So un means 1, 0, 1, right? So answer will be D is the correct answer. Okay. Un means 1, 0 means nil, then again 1. Okay. So unanilinium, that means 1, 0, 1. Oops. So sorry. IUPAC symbol for the element, that is 119. That is going to be nedium. Okay, inidium, right? So ininium, right? Okay, so that is going to be UUE, right? But let me tell you one thing. There is a table in your NCERT, right, where the actual name of the scientist they are given. Okay, the actual name based on the scientist name, like Rotengium, like Laurentium, these kind of names are given to you. From there till now only 2 questions are asked. Usually if you don't want any risk, you can also do that. If you want to skip, you can skip, but I would advise you just go through the previous year question of that. Otherwise it's not very important, it's not frequently asked, right? That is not in the frequently asked section, but yes, surprisingly the question has been asked from there, right? Okay, next is the element having greatest difference between first and second ionization energy. Greatest difference between first and second ionization enthalpy. First and second ionization enthalpy, the greatest difference. If you see scandium, barium, potassium, calcium. Potassium can be the answer. I'll tell you why. Because it is argon 18, then you have 4s2, right? If you take out 4s1, sorry, it is argon 18, 4s1. If you take out 1 electron from here, after taking out 1 electron, it will become argon 18, which is a very stable state. So first ionization enthalpy will be easy. First IE1 will be easy, but taking out electron from this IE2 will be very high. That is why there will be a great difference here. So answer will be D is the correct answer. Okay, D is the correct answer. Next question is the correct order of atomic radii of C, Cs, Al and S. Atomic radii, guys. So correct order of atomic radii they are asking you. There are 3-4 things that are given to you. Carbon you have, aluminium you have, sulfur you have. Cs is somewhat here. Here you have aluminium is group number 13, right? Okay. Carbon is group number 14 and sulfur is oxygen, carbon. Then you have carbon, nitrogen, oxygen, sulfur. This is the situation. Hai na? This is the situation. This belongs to group number 1, right? This is group number 13. This is group number 14. This is group number 15. Sorry, 16. Group number 16. This is the situation that you have, right? We know that actually what happens along the period down the group. Atomic radius, the size will decrease here, the size will increase here. That means definitely CS is going to have the maximum size here, right? Okay. So after that, if you talk about the minimum size here, if you talk about the minimum size here, right? Out of carbon and sulfur you have to predict, right? Okay, out of carbon and sulfur which will have the more size. We know that along the period size decreases, down the group it increases. So here if the size is decreasing, here it is increasing a little bit, right? So definitely carbon is going to have more size as compared to if the size is increasing here it is decreasing. Carbon will have more size, right? Okay, so answer should be D. Wait a minute. Aluminium, sulfur. This is having the maximum, right? We are comparing this with 14th group, right? Sizes, this is 14th, this is 16th. Size is decreasing here. If size is decreasing here, just give me a second. If size is decreasing here, we have to talk about these two elements, right? So these are also diagonal to each other. If the size is decreasing here, it is increasing a little bit, right? But the increment is not that much, right? So this means this is experimental thing, okay? That the increment is not that much. So the answer will be this. Because in these kind of situation where you don't have a direct relation here, here the size is decreasing, then here the size is increasing, right? Okay, here the size is increasing. Decrement is there, increment is there. Both are happening here. For example, if you talk about the oxygen here, here it is decreasing, then again it is increasing, but the increment, right? Increment, if you talk about, that is more as compared to the decrement, right? Okay, down the group size increment is more, right? So that is why sulfur will have more size as compared to carbon. So answer will be A is the correct answer, right? Now, next is the electronegativity of the following elements increases in which of the following order. So again, you have carbon, nitrogen, silicon, phosphorus. So different compounds you have, different groups you have. So if you talk about carbon and silicon are present here, nitrogen and phosphorus are present here, right? We know that along the period down the group, here electron negativity will decrease, here electron negativity, sorry, it will increase over here, right? Electron negativity will increase, electron negativity will decrease. That is why if we compare between nitrogen and, if you compare between nitrogen and phosphorus, right? Nitrogen and phosphorus, if we're comparing between these two things, then definitely phosphorus is going to have the more, nitrogen is going to have the more electron negativity. That means nitrogen and phosphorus are going to have more electron negativity here, right? Okay, so out of carbon and nitrogen, nitrogen is going to have more, right? Nitrogen is going to have more, right? Okay, then if you talk about silicon and phosphorus, phosphorus is going to have more, right? They are asking you increasing order, right? Phosphorus is going to have more. If you talk about down the group, it is decreasing, right? We have compared these two things. Silicon is less than, definitely less than carbon, phosphorus is less than nitrogen. So the pair, if we combine all these things together, C is turning out to be the correct answer, okay? C is turning out to be the correct answer if we compare all these things together. Okay guys, everyone got it? What you need to check is both the things, okay? So here it is increasing. So I have compared firstly these two things, that nitrogen is greater than carbon. That is only possible here and here. So this is eliminated, right? What about this next thing? That is silicon is greater than phosphorus is greater than silicon. That is also here and that is also here. But we know that overall carbon should be greater than silicon. But here silicon is greater than carbon. So this is also eliminated. Answer is C is the correct answer. Okay, got it everyone? Chalo. Next question on your screen we have electron gain enthalpy of fluorine, chlorine, bromine. Again, this is also a very important question, right? Very important question, right? Now again the exception, what they are asking you, chlorine, fluorine, chlorine, bromine, iodine. Why? Because it has an exception. So you don't need to learn any value here. Just remember that there is a trend where we know that if you talk about fluorine, chlorine, bromine, iodine, down the group, if you talk about the electron gain enthalpy, size is increasing, electron gain enthalpy, right, that should decrease. That means fluorine, then you have chlorine, then you have bromine, then you have iodine. It should be the answer. But fluorine, because of very small size, it is not able to gain the electron. That is why chlorine will have the maximum, right? So chlorine should have the maximum. Maximum where I can see for chlorine. Chlorine, it's not the maximum. Here also chlorine is not having the maximum. Here also chlorine is not having the maximum. Here I can see chlorine is having the maximum value. So answer will be this, right? So firstly you have chlorine, right? Then fluorine has jumped to the second position. Then fluorine, then bromine, then you have iodine. That is going to be the correct answer. Okay? Yes, everybody? Everyone in the comment section, is that clear? Everyone here, is that clear to everyone or not? Okay, chalo. Now, next is ionization enthalpy for the elements of group 13 follows the order. Now we are talking about the ionization enthalpy, right? Guys, firstly, so you need to remember the full, like what is the general value here. General value is ionization enthalpy. Size is increasing here, size is decreasing here, ionization enthalpy will increase, ionization enthalpy decreases over here. They are asking you in the group, right? So in the group it is decreasing. It is Bal, Gai, Indian, Tel se, right? This is group number 30. Now what you need to see here, that it should decrease. That means it should be Bal, Gai, Indian, Tel. But this is not the correct order. The order is very weird. And we represent that order by this W. Okay? We represent that order by this W. Okay, so what exactly this order is? BAL, GA, Indian, Tel. Right? So basically, boron, after boron, things will change here. Right? After boron, things will really change here. Wait a minute, I have drawn the W wrong here. Wait a minute, let me just draw it right. It will be a twisted W, okay? It will be a twisted W. So now you can see that maximum, basically this is going to be the correct answer, right? So this is a different way of writing it, right? So if I tell you what will happen, first you will have boron, right? Firstly there will be boron, right? Then you will have, this is decreasing, this is increasing, then again decreasing, then again increasing. Then you will have Indian, then you will have thallium here, right? Then you will have gallium, then you will have aluminium, then minimum you will have is indium. This is what you're gonna have, right? Okay, so this is the same thing they have written in a very different format, right? So usually you have to remember this W, and this is the order that you will have. B, Tl, Ga, Al, iron, right? Now, here what you will see, boron is the maximum, then aluminium is less than that. Yes, that is right. Aluminium is less than that is also right, that is also right here, that is also right here. No, that is wrong here. Here it is wrong, here also it is wrong, right? Here it is wrong, here also it is wrong, here it is right, right? Then you have, it is decreasing, but we know that gallium has more as compared to aluminium. Gallium has more, that is why it is eliminated, that is why this is the correct. Then gallium has more than indium, gallium has more than indium, that is also correct. Indium has less than thallium, indium has less than this, that is also true. So answer is D is the correct answer, okay? This order you have to remember by this W. Then you have to see this kind of order. How you will see? Just compare it with this one. Boron is less than aluminium? Yes. Aluminium is less than gallium? Yes. Gallium, then it is it is greater than indium? Yes. Okay. Thallium is greater than that? That is also right. Okay. So by this you can say D is the correct answer. Next is the element which shows least metallic character. Metallic character. Okay guys, the element which shows least metallic character, right? Least metallic character. Now if you talk about group number 13, right? Right? If you talk about group number 13, here down the group metallic character will increase. Boron will have the minimum answer will be 2. Okay, boron will have the minimum answer will be 2. Okay, chalo. Next is, which of the following has the lowest melting point? That means they are asking you which of the following will have the lowest melting point. Now guys, if you talk about the melting point, this is exactly an exception, right? Basically gallium is so, like, it is such a low melting point that we can even melt it in our palm, right? So that is why it has extremely unexpectedly low melting point. So answer will be C, gallium is the correct answer. Is that clear to everybody here? Which of the following elements is unable to form MF6? MF6 3 negative ion. Which of the following is unable to form this kind of ion? Anybody in the comment section? Gallium, aluminium, indium and boron. Answer is boron. It is based on a very important property that all elements of first element, you can say first element of any group will not expand its covalency, not expand the covalency. Basically, it will not be able to expand the covalency because it does not have any vacant d orbitals. That is why boron cannot make MF6 3 negative kind of atom, compound, right? Next is thallium shows different oxidation states because thallium shows different. See, if you talk about, see, if you know this thing now very easily, just remember the order here. We know that down the group what is happening. Here you have the addition of 3d. Here you have the addition of F electrons. So it has the maximum F electrons. That is why, because of the maximum inert pair effect, it is going to show a different behavior. Right? Okay, guys. Okay, chal. Now, next is going to be the stability of +1 oxidation state among the following, right? Next is the stability of +1 oxidation state among the following. Guys, wait a minute. Is this the answer? Okay, chalo. Wait a minute. Okay, so if you say Bal Gaye Indian Tail, we know that down the group, always remember, down the group, lower oxidation state will increase. LOS will increase down the group. Whenever you are going down, loss is going to happen. Na? So lower oxidation state is going to, stability is going to increase. So +1 oxidation state is lower oxidation state. So down the group it will increase. So answer will be B is the correct answer. B, AlGanin and then Tl. So B is going to be the correct answer, right? Okay. Now, next question is aluminium chloride is acid in acidified aqueous solution forms complex A, in which hybridization Al is B, where what are A and B? Now, this is a very, very unique question. Okay. So now, let us see. Aluminium chloride, if you talk about AlCl3, it is going with acidified aqueous solution. Beta, this is basically a concept of DNF block also, right? Not DNF block, so sorry. So basically, it is not a concept of DNF block. This is basically, it is going to form coordination entity right here. Reason is aluminium has vacant d orbital, so it can expand its octet. Right? Now you just need to see what kind of octet it can form. Definitely this doesn't exist only. AlH2O4 doesn't exist. AlH2O6 will exist. So this is the compound that is going to exist here. Now you need to tell me what is the hybridization here. For hybridization, simple, this x plus 0 is equals to +3. X is going to be +3 oxidation state, right? Okay, so here what you will do, you will just see the hybridization here. What is going to be the hybridization? So sorry, right? Okay, so I already told you the answer. So hybridization, how to calculate? Just by writing the electronic configuration here. What you need to remember is these d orbitals, you will not see here the d orbitals, but these d orbitals will be totally vacant, right? The second element of any group is going to have vacant d orbitals. That is why outer orbital complex will exist here, not inner orbital complex, right? If we had coordination chemistry, then we would have calculated this. But in this case, inner is not possible only because it does not have d orbitals fully filled or half filled or whatever. They have totally vacant d orbitals, so that is why we don't even need to solve this, right? So answer will be outer. So answer will be B is the correct answer. Okay, answer will be B is the correct answer. Okay, yes everybody, bipyramidal. The correct statement regarding group 13 oxides are boron trioxide is acidic in nature, oxides of aluminium and gallium are amphoteric, oxides of indium and thallium are basic in nature. Right? Okay. Boron trioxides, that means if you talk about BO3, these oxides are acidic in nature. Right? If you talk about down the group now, this. Down the group, there is a specific behavior that they are showing. Down the group, basicity always increases. That is why boron oxide is acidic in nature. Yes, that is right. That is true. Right? If you talk about oxides of aluminium and gallium, they will be amphoteric in nature. That is also right. And oxides, mark one more important topic, that is oxides. Neutral, amphoteric, then you have acidic and basic. Okay, these four kind of oxides you need to know, right? Okay, oxides of indium and thallium are basic in nature, definitely. So answer is all of them, all the statements are true here. So answer A is the correct answer. Which of the following does not react with aqueous NaOH? If you talk about the aqueous NaOH, which of the following will not react with aqueous NaOH, guys? Very simple answer. There is one compound that is always in the exception. There is one compound, right, that is always in the exception. Can you tell me what is that compound? Boron was always giving exceptions. I can't form, I don't have vacant d orbitals, I'm so sorry. I have very small size, I'm so sorry. I have very, I would say, I have not the capability of taking more electrons, right? That means I cannot expand my covalency. Okay. I am a non-metal. Okay. I have least metallic character. Okay. My oxides are extremely acidic. Okay. Right. So boron is also saying that I will not react with NaOH also. Right. So I have this is very heavy, it's throwing so many tantrums. Boron is basically always throwing the tantrums here. Right. Okay. Now, next is boron forms covalent compound due to, right? Why it is forming the covalent? I told you boron is fully tantrums. It having small size and having high ionization energy. That is the reason it is not able to form the covalent. It is not able to form the ionic compound, right? Boron, it will exist in covalent compounds, not in ionic. That is also one of the properties of boron. That is very exceptional property, right? Okay. Chalo. Next is NH3BF3 form adduct readily because what they will do, right? If you talk about NH3 here, if you talk about BF3 and NH3, can you tell me the reason here? See, NH3 has lone pair of electron. And if you talk about BF3, it is electron deficient, it is electron rich. So it will donate 2 electrons here. That is why adduct is formed. That means a coordination bond is formed between them. That is why adduct is formed here. So answer is A is the correct answer. A coordinate bond is formed here. That is why adduct is formed here. Okay, got it, guys? Next is boric acid is polymeric due to. Boric acid. First, you need to tell me what is a boric acid, everybody. What is a boric acid, everybody, in the comment section? What is a boric acid, guys? What is a boric acid? Right. Now, firstly, let us see the boric acid here. Right. Boric acid is basically H3BO3, or you can see BOH thrice. That is called the boric acid. See, the compounds, usually students will skip the compounds, but here I have just picked those questions. They were unlimited questions. If you pick out the years when they have not eliminated, they have written full syllabus of P block was there, But now full syllabus is not there, right? But still I don't have trust, right? I have trust issues. So that's why I have picked up some questions, because what I feel is reactions they will definitely not ask you of compounds, structures they can ask you. So especially I have picked out only those questions where you have structures. Other questions I have not picked out. If you want to skip the compounds, you can skip, but please do these questions at least. At least you should know an idea, because in these questions only I'll give you an idea about these compounds, right? Now, boric acid is polymeric. Now, because of this is B, this is OH, this is OH, this is again OH. Here it is going to form the hydrogen bonds. That is why it will be polymeric in nature. So, this is BO. This is one compound. As you can see, this is basically your one compound. This is one compound. This is one. Okay, it is going to make hydrogen bond with the other, right? So, presence of hydrogen bond is the reason. Okay, got it? Chalo. What is false in case of boric acid? Now, boric acid is what? Boric acid acts as a tribasic acid, right? It is tribasic acid. Okay? It is a planar structure. It is a monobasic acid. It is soluble in water, right? Okay. So definitely, even if you don't know, then also you will get to know either it can be tribasic or it can be monobasic. So definitely it is soluble in hot water. It is a planar structure, right? But is it tribasic or is it monobasic, right? So usually when students see that, ma'am, this is having OH, ma'am, OH, ma'am, OH, they get very excited. They say that, ma'am, yes, it is tribasic in nature. But that is what is very important. That is N factor. Its N factor is 1. It is monobasic in nature. It is not tribasic in nature. It is monobasic in nature, not tribasic. Right? This is the question this is the mistake that students can do. And boric acid is a weak monobasic acid. Right? Okay. It is not protonic acid, but acts as Lewis acid by accepting electron from the hydroxyl ion. Again, a very, very important point. That means usually acids are of two categories. One is which can donate the proton. One is which is a Lewis acid. That means it is electron deficient. Because of this electron deficiency of this boron, it is an acid not because of hydrogen, but because boron is electron deficient. So this is a very, very important point, that this is not a protonic acid. This is Lewis acid, which is electron deficient. That is why it is going to accept the electron. That is why it is acidic. Next is the bonds present in borazole or inorganic benzene. This is very important. Right? Again, I am telling you, just go through the structure. Okay, that is important for you. Right? Just go through the structure. Now, this is same as benzene only. When you will see this structure, now this is same as benzene. What you will see here, just like in benzene, you have this thing, right? You have 1, 2, 3, 1, 2, 3, 4, 5, 6, 5 hydrogen over here, right? Same thing you will do, but just in alternate position, you will have boron and nitrogen, boron and nitrogen, boron and nitrogen, right? That is the structure. That is why it is called inorganic benzene, right? So here too easily you can calculate the sigma bond. That is why I have picked up this question. Right? So these are simple questions, okay? So pi bonds, we know that it is having 3 pi bonds. It is having 6, 7, 8, 9, 10, 11, 12 sigma bonds. Okay? Chalo. Next is very important, that is diborane, the structure of diborane. If you talk about diborane, I told you this thing, if you remember this thing. Guys, if you remember, we have done this thing. Right, I told you this, that it has a structure, right, BHH. Here it is going to make banana bonds, right, and HH. Basically, it is having 4 two-centered. These bonds are 2-centered 2-electron bond. So it is having 4 two-centered 2-electron bond, and it is having 2 3-centered 2-electron bond. So answer will be 4. 4 2-centered 2-electron and 3 3-centered and 2 3-centered 2-electron bonds. Okay, got it? These are the banana bonds. So answer will be D is the correct answer. Next on your screen we have which of the following compounds Which of the following compounds is not matched correctly with its structure? Everybody in the comment section, answer it. Everybody in the comment section, answer it. Which of the following is not matched with its structure? We have done this. We have already done this, guys. Anybody in the comment section? Boron trichloride, okay, is not matched. You have borazine, diborane, that is so correctly matched, right? Borazine, that is also correctly matched. Boron trichloride. Now I have one problem here. Definitely this is not correctly matched. So this is definitely the correct answer. But here, this is BCl3. In BCl3, there should be no lone pair, right? Okay. So the question should be like this. Okay. Question should be like this, right? In boron, they should not have lone pair because this is definitely showing the wrong. This is all the atoms are here and there. This is like Al, Al, Cl, Al, El. What is this? Aluminium chloride. Definitely not the correct answer. Right? Okay? Understood? Chalo. Now, next is, here just eliminate this thing because these lone pairs should not exist here. Right? Okay. Now, next is, carbon and silicon belong to group 14. The maximum coordination number of carbon is commonly occurring compound is 4. Whereas the silicon is 6. This is the same thing. Why boron was behaving differently? Because of it does not have vacant d orbital. Similarly, it will also not have vacant d orbitals. Right? Okay. Similarly, because of the availability of d orbitals of silicon, it can expand the octet always and always when some first element of a group is compared to the second element. The reason will be this only, availability of d orbital, it can expand, but the first element will not be able to expand. Right? Same with nitrogen and phosphorus, same with boron and aluminium, same with this, right? Inert pair effect is most prominent in which of the following? Inert pair effect, guys, same question I have done in group number 13 as well. Now this is for group number 14. If you see this, 𝐂𝐡𝐞𝐤 𝐿, this is PB, that is lead, that is like the one which is having F electrons also. That is why maximum it will have the inert pair effect. So answer will be B is the correct answer, right? Next question is, mark which of the, you have to mark it, which of the oxide is amphoteric in nature? Which oxide, mark the oxide which is amphoteric in character. Amphoteric, guys, very, very important and very simple, right? Okay, this should be on your tips, right? This should be on your tips. Aluminium oxide, zinc oxide, tin oxide, right? These are amphoteric in nature, right? Okay, so answer will be SnO2. This is amphoteric in nature. I'll also give you one chart, right? I'll give you that in the Telegram channel. Okay, on my Telegram channel, I'll send you one chart where I'm going to tell you that basically what are neutral, acidic, basic, like full chart of that, right? Okay, chalo. Next is, which of the following are not correctly matched? Can you tell me which of the following are not correctly matched? Again, based on amphoteric oxides, this oxide, that oxide. Silicon oxide is not correctly matched, guys. Lead oxide, wait a minute. Here we didn't have lead oxide, na? Haan. Lead oxide is amphoteric in nature. Okay, lead oxide is also amphoteric in nature. Germanium is also acidic in nature. Carbon monoxide is neutral. NO2 is neutral, right? These are, N2O is neutral. These are the neutral oxides, right? SiO2 is definitely not amphoteric oxide. It is the acidic oxide. So answer will be which of the following are not correct? So answer will be fourth is not the correct. So B is going to be the correct answer. Okay, B is going to be the correct answer. Got it? Got it, guys? Chalo. Which of the following halides is most stable? If you talk about the halides here, what about the halides? Everybody, what about the halides? If you talk about the halides here, which of the following halides is most stable? Halides. So we know that if you talk about the halide stability, right, you have CC, it should be CCl4, this is so definitely not, right, CBr, CCl, CF. So down the group fluorine, chlorine, bromine, iodine. Stability, down the group it will decrease, right? Fluorine will have the maximum stability here, right? So answer will be CF3 is the correct answer. Okay, right? Okay, okay, beta. Next is you have the stability of silicon, germanium, tin, lead increases steadily in the sequence. Basically, they are asking about +2 oxidation state. We know that this belongs to group number 14. That means it is NS2 NP2 configuration it is. Lowest oxidation state is +2. Higher oxidation state, that means that is including both of them, is +4. So here basically they are asking you the stability of lower oxidation state. Lower oxidation state, down the group stability will increase, right? Tin, this will be the answer. 𝐂𝐤 𝐎𝐮𝐫. So this is going to be the correct answer here, right? Okay. So answer will be D is going to be the correct answer. Okay. Okay, students, everybody. Chalo. The main reason they are saying, the main reason that silicon chloride is easily hydrolyzed as compared to carbon chloride is that, see, silicon chloride is easily hydrolyzed. That means it can adapt, like it can have H2O molecules along with it. Reason being because it can expand the covalency. Silicon can extend its coordination number beyond 4 because it has vacant d orbitals. But carbon does not have vacant d orbitals. See, third time this same question has been repeated. In boron, in silicon, so 2 times they have repeated the same question, right? So answer is what? Same thing, right? So it's not that difficult. Same type of questions are getting repeated here. Catenation, now they are saying that catenation linking of similar atoms, how it is going to decreasing or increasing? So definitely it is going to decrease, right? But how? But how? Everybody? It is going to decrease. Okay, it is also decreasing. It is also decreasing. This is not the correct answer. This is not. From these two, what is the correct answer? Here they have shown a normal decrement, right? But here they are saying that carbon is very high as compared to silicon, which is correct. Then it is decrement. Then germanium and tin are almost similar only. So here answer will be B is the correct answer. Okay, answer will be B is the correct answer. Okay, got it? Chalo. Next question on your screen is the element that does not show catenation among the following. Okay, the element that does not show catenation among the following. That does not show catenation among the following p block elements. That will not show any catenation. Just now we have done the same question. Have they shown lead here? No, right? So lead will not show any catenation. Same question is getting repeated. Same question, same question. Okay, then you say, ma'am, previous year questions are not repeated, right? Which of the following is incorrect statement? Now you need to tell me which of the following is the incorrect statement, right? PbF4 is covalent in nature. SiCl4 is easily hydrolyzed. GeX4 is more stable than GeX2. Okay. SnF4 is ionic in nature. You have to tell which is the incorrect statement here. Incorrect statement. So if you talk about SiCl4, that though we have seen now only that it is the true statement, right? GeX4 is more stable as compared to this. We know that down the group, lower oxidation will increase. But it is, germanium is over here. So germanium will be in between this. So germanium is not down though. It is not the lowest element of this group. So that is why +4 oxidation state is more stable as compared to +2. So this is also true. What about this one? SNF4 is ionic in nature. That is right. That SNF4 in F4 is definitely ionic in nature. If you talk about PbF4, that is also ionic in nature because the electronegativity difference is good. Right? So here incorrect statement is A is the incorrect statement. Right? Okay. Okay. Chalo. Next is which of the following species is not stable? Which of the following species is not stable here? So if we talk about the following species which is not going to be stable, guys, which is not stable here, everybody in the comment section which is not stable, right? A, okay, right? Yes. A, B, C, D, which is going to be unstable species. Silicon, tin, germanium, they are saying that how they are going to form the compound. Now, this is written in your NCERT. This is a line of NCERT that silicon with chlorine is not stable. Proper answer they have given. It's a very, very important line of NCERT, right? Now, what is the explanation for this? That why silicon with fluorine is stable? The proper explanation is this is stable, but this is not stable. This is not stable. So the proper explanation for this, what they have given is that chlorine is bigger in size as compared to fluorine. So for silicon to accommodate 6 chlorine atoms, it's not possible. There will be so many repulsions. That is why CiCl6 2 negative is not a stable compound. Right? Okay. Now, the reducing power, divalent species decreasing in the order. Reducing power. Okay. Reducing power, guys, you have to see here. Everybody, reducing power, you need to check here. Right? So, if you talk about the reducing power of the species here, so down the group exactly what will happen? The reducing power will decrease. Okay, so this is down the group reducing power will decrease. Right? Okay, so you can say that GES and PB. So this is going to be the correct answer because down the group reducing power is decreasing. So answer will be A is the correct answer. Right? Okay. Let me see why the students are not joining. I can't understand that thing though firstly. Why so much hard work you ask me to do when you're not going to join the session only? Huh? Hmm. Hanji beta, what you want? I don't know what you guys want. Do you want me to like sing here? Right? What do you want me to do? Huh? Whatever I do, I can't see that you guys are even interested in learning anything. Only few students are interested. Hai na? Only few students here are interested here. Otherwise, so I can't see. So I'll give you the break. After that, I'll see if some students are joining or not. Otherwise, so I'm gonna stop this class, right? And stop the day 2 and day 3 also. There is no benefit. In the start, you all are very excited, but in the end, the energy is such low, such like literally very disappointing. Yeah, very disappointing. So it is because of the inability of NS2 electrons, the valence shell, to participate in bonding. Now they are saying that which is reducing and which is oxidizing, right? Okay. So if you talk about this thing, now we know that down the group lower oxidation state is more stable. That means Pb is more stable in Pb2 positive as compared to 4 positive, and tin is more stable in tin 4 positive as compared to 2 positive. That is the reason we can say that from 2 positive to 4 positive, right, it will not go. That is why 4 positive wants to get converted into 2 positive and 2 positive wants to get converted into 4 positive. Here that means the oxidation number will increase and here the oxidation number will decrease. And that is the reason when the oxidation number is decreasing here, that means it itself is getting reduced. So it will oxidize something else. So it is a good oxidizing agent. It is a good reducing agent. So answer is going to be D is the correct answer. Okay. D is going to be the correct answer. Okay guys. Chalo. Now, next question is, which of the following statement is not correct for nitrogen? Right? Which statement is not correct? It is its electron activity is very high. D orbitals are available for bonding. It is typical non-metal. Right? Its molecular size is very, very small. Right? Okay. So, fourth or fifth time the same question they are asking you. Fourth or fifth time the same question that they are asking you. Yes, everybody, same question, right? That the availability of d orbital, right? Nitrogen will not have the availability of d electron, right? Right? Nitrogen is the first element of this group, so it will not have the availability of d electron, right? Next is the 3 important oxidation states of phosphorus. If you talk about the 3 important oxidation state of phosphorus, see it is NS2, NP3. Now tell me what is the 3 important oxidation states. Now guys, tell me what are the 3 important oxidation states. Lower oxidation state, higher oxidation state, and oxidation state because of the electron negativity. Lower is this +3 oxidation state, which includes only P. Higher is both of them, that is this. And because of electron negativity, it can lose also, it can gain also 3 electrons, so it will be -3. So answer will be -3 plus 3 and plus 5. Answer is A is the correct answer. Okay? Okay? Yes guys, A is going to be the correct answer. Next is, which of the following has highest p-pi bonding tendency? Highest p-pi bonding tendency. Here I can see the hard work appreciation here. Chalo, I'll do one thing, I'll just stop this, okay? I'll just stop. If you don't want to study, then you could have just told me that, ma'am, we don't want this series to go, right? There was no need of firstly encouraging me that, ma'am, please prepare this, ma'am, we will join, ma'am, we will attend, right? But I can't see anyone here. So I'm very disappointed. I'm going to just end this, right? Okay, I'll just give you the break, right? I'll just solve this and after that I'll give you the break. Which of the following has highest p-pi bonding tendency? So down the group, what will happen? Down the group, d electrons will be involved. That is why p-pi bonding tendency will be maximum in nitrogen. That is first one. Nitrogen will have the maximum p-pi bonding, right? Okay, guys, my mood is literally now very off. So I'm going to give you break here. I'll see that I don't know why students are not coming. What is the reason? Right? I think they need something else only. है ना? They don't need pure content or nothing they need. They want me to come here and do time pass. Pure. Right? So I'll just give you the break. Right? Otherwise, so you know that ma'am doesn't need any break. Ma'am can even teach for 5 hours. Right? Beta, what to do now? What to do? When I see the live watching, when I see that okay, the work is not appreciated. For example, just tell me how you felt then when you were getting 700 marks, 670 marks, 680 marks, and still you were not getting into any government college, right? Or not even any private college. You were getting bad. You were feeling bad, right? Even I am a human being, right? Okay. So even I'll feel bad that why these students are not interested in good content, right? I've like literally picked up the best questions for you, right? Now, earlier you were saying that, ma'am, please, earlier I was teaching slow because I thought that maybe you need more concepts here. But then I understood that you are here for revision. Now I'm even picking up the speed here. Then also I see that students are disappearing. So that is very hurtful, okay? Chalo. So now you will be there in the comments, hai na? You will be there now. So let's pick up the speed again. Next question guys, on your screen we have the next question, that is, which one of the following is the lowest boiling point? Lowest boiling point. Which one of the following will have lowest boiling point? So usually we know that boiling point is based on the electronegativity, right? So down the group boiling point, down the group electronegativity decreases. That is why what should have happened, that nitrogen should have maximum, then phosphorus, then you should have this, right? But in reality, you know what happened? In reality, because NH3 is forming the hydrogen bond here, right? It is forming the hydrogen bond. So what will happen? This NH3 is not going to follow that order, and instead this, which was the following, will have lowest. Instead this will have the lowest. Wait a minute. Yes. Which one has the lowest boiling point? Now they are asking you. So down the group boiling point is definitely going to increase. Yes. No. Opposite I told you. NH3, PH3, then you have ASH3, then you have SBH3, right? Down the group, what will happen? It should have increased. The order should be like this. But because of the hydrogen bonding of this NH3, right? It will follow the opposite order, that will be over here, right? So that is why answer will be PH3 is going to have the lowest boiling point. Okay, PH3, yes. Okay, so PH3 is going to be the lowest boiling point here. Then is, this is the order, okay. So NH3 was supposed to be here. It was supposed to be here, but actually it is at this place, right? Okay, so lowest is for PH3. Next is most acidic among the following. So acidity will depend on the oxidation number, right? Acidity will depend on the oxidation number. So if you see here, which is the following is most acidic, right? We know that down the group, firstly acidity decreases. This is NP and this is ES. So definitely nitrogen oxides are going to have the maximum acidity. And nitrogen oxides also, we have two oxides, N2O5, N2O4. This is going to be 2x minus 10 is equals to 0. X is going to be, this is 10 by 2, 5. This is going to be 2x minus 8 is equals to 0. So x is going to be plus 4. So more is the oxidation number, more is the acidity. More is the oxidation number, more is the acidity. So out of these two, answer is going to be A is the correct answer. Okay, A is the correct answer. Now next question on your screen is the correct order of basic strength is. What about the basic strength, guys? What about the basic strength? These are the hydrides. Okay, in hydrides we have very, very important things. Okay, in hydrides we have something very, very important. that reducing power, thermal stability, these things will increase down the group, right? Acidity will increase down the group. But basic strength is going to decrease down the group. So answer is going to be C is the correct answer, because basic strength, there is no exception here. Basic strength decreases down the group. Okay, basic strength decreases down the group. Who ate, ma'am? Who ate, beta? Beta, this is oxygen, na? 4 into 2, 8. Right? 4 into 2, 8. Minus 8 is equals to 0. Right, Manu? Okay. Now, next is which represent protonic acid, which of the following statement is correct here? Now they are asking you, with respect to protonic acid, which of the following statement is true? Protonic acid is the same thing that we have done before, right? Same thing, beta, we have already done here, right? Now, if you talk about the protonic acid, that means which is going to donate the protons, right? Okay, which statement is correct here? Right, which statement is correct here? If you talk about the hydrides here, right, hydrides here, right, same question is being repeated here, right? We have just done this question. The correct order of decreases, basic strength, I told you it decreases down the group. So we have done here that NH3 has more as compared to PH3. Same thing I am writing here, PH3 is less basic, definitely. So B is the correct answer. Right, this is the same statement, same question is being repeated here, right? Okay. Next is the solid PCl5 is. Solid PCl5, guys, very, very important. Very, very, very important. Solid PCl5, very, very, very important. It exists in a very beautiful manner, right? It exists as one cation and one anion, right? It exists as one cation and one anion, that is PCl4 and PCl6, right? It exists like this. So that is why I answered with PCl6 negative, right? So this is not the correct. Ionic solid with PCl4 positive, PCl6 negative. This is definitely octahedral and this is tetrahedral. So answer will be D is the correct answer. Okay, D is the correct answer. Okay, guys, chalo. Next question. Mark it, very, very important. Next topic is going to be oxo acids of phosphorus, right? From oxo acids of phosphorus, you will see so many questions are asked directly on oxo acids of phosphorus, and very simple questions are asked here, right? Okay, so I told you that don't focus on the reactions, but don't skip oxo acids of phosphorus and sulfur, especially the phosphorus, right? Which of the following, now they are asking which of the following oxo acids of phosphorus has strongest reducing power? Reducing power means which has more hydrogens, hydrogens attached to phosphorus, not to oxygens, right? Attached to phosphorus. If you talk about, chalo, P double bond O, if you talk about, you need to have maximum here. So that means oxygen need to be very less, right? So oxygen is 3 here, 2 here, 4 here. Less are over here. So it will be OH, H and H. This is H3PO2, right? What about H3PO4? H3PO4 will be OH and OH, right? What about H3PO3? This will be OH and H. So maximum hydrogens are in case of H3PO4. That is why answer is D is the correct answer. It has a maximum reducing power. Okay. Got it? Got it, students? So very, very important. Number of POP bonds in cyclic metaphosphorus acid, right? For that, first you need to know the metaphosphorus acid here, right? Okay, for that you need to understand the metaphosphorus acid. This is the metaphosphorus acid, right? It's also an oxo acid only. Here they are asking you POP bond. So this is 1, this is 2, this is 3. So answer will be 3 POP bonds are present here, right? Okay, directly the structures, from structures they can ask you the questions, right? Okay. Next is again from structures only these kind of questions they can ask you. Now we have group number 16. What kind of questions they can ask you from? Metaphosphoric acid. Okay, so now what kind of question they can ask you from oxygen family? Right, first thing they are asking you about the ionic radii. Right, first thing they are asking you about the ionic radii, guys. Ionic radii is the no exception over here. Ionic radii will increase down the group, right? Okay, so answer is going to be, there is going to be no exception, so answer is going to be A. There is no exception on this. So this question, right, this question is like a very, very simple question, okay? Now, electron affinity of sulfur, important question here. Electron affinity of sulfur, this is same as nitrogen and phosphorus. This is same as nitrogen and phosphorus, guys. Same as nitrogen and phosphorus. We know that down the group, right, electron affinity should decrease. That means oxygen should have the maximum electron affinity, but due to the small size of oxygen as compared to others and two lone pairs present on it, that is why its electron gain enthalpy, that means the power, or you can say the ichha is what? The ability, the need to take electron is very less because of very small size electronic repulsions. That is why sulfur has more electron affinity as compared to oxygen and helium. Okay, more compared to oxygen but less than, definitely not, equal to this, definitely not. So answer is going to be A, is going to be the correct answer, right? Okay, next is oxygen and sulfur both are members of same group in periodic table, but H2 is liquid by H2S is gas, because we know that here you will have hydrogen bonding, है ना? So molecular weight तो no, electronegativity sulfur no, H2S is weak. Water molecules have weak hydrogen bonding between them. Yes. So answer is because of the hydrogen bonding, it will exist as liquid, but H2S does not have hydrogen bonding, so it will exist as a gas. Okay. So answer is D is the correct answer. Okay. Now the speed is fine, or am I fast now? Now the speed is fine. Should I go with the same speed, or should I decrease the speed, or should I increase the speed more? Everybody. Which of the following hydrides is more acidic? Most acidic. Hydrides is most acidic, right? That means down the group acidic character increases. Okay, down the group acidic character beta increases. For hydrides, acidic character will increase down the group. So increase means the maximum will be usse te. So it will be maximum for H2T, that is A is the correct answer, right? Okay, A is the correct answer. Next is going to be, which is the correct thermal stability order of H2E? Very good. Thermal stability order is same as acidic order, right? It is same as acidic order here. Thermal stability order, wait a minute. Thermal stability down the group size of the the size of the atom will increase, right? So size will increase, bond length will increase, so thermal stability will decrease. Yes, thermal stability will not increase, it will decrease, because the bond length is going to increase, the size will increase down the group, bond length will increase, so it is easy to break that, right? So thermal stability is going to decrease down the group, right? So where it is decreasing, there is no exception in hydrides. Okay, only in boiling point, melting point you will see the exceptions. So answer is going to be oxygen is maximum only in this case, right? So answer is going to be C. So you can just write it here. Thermal stability also decreases down the group. Okay, it also decreases down the group. Okay, thermal stability beta, it also decreases down the group. Okay, it will decrease down the group. On going down the group, bond dissociation enthalpy of hydrides family decreases. Why? Because bond is longer, it is easy to break that. Thermal stability is less. less energy is required here. Therefore, thermal stability also decreases. Okay, so answer is going to be 3. Right? Okay, next is all the hydrides, right, except for, you can just write one thing here. Dekho, for hydrides, you can write one thing, decreases, and you can write here increases. Acidic, no, right, basicity, stability, it will decrease. Bond association energy will decrease. Bond strength will increase. Wait a minute, bond association energy decreases, strength also decreases, right? Bond length is going to increase. Bond length will increase. Acidity will increase. Reducing power will increase. Okay? Basically, 5-6 questions you can answer from here. 5 to 6 questions you can answer from only this thing. Last 4-5 questions that we were doing are based on this particular concept only. They are asking you basicity, stability, bond association, length, acidity, reducing power. Based on this thing only, there is no exception. Hydrides are like this only, whether you talk about group number 15 or 16, right? So all the hydrides except for this possess reducing property. Increases from reducing property, definitely increases. Identify the hydrides. Okay. Now they are asking you to identify that hydride except one which possess reducing property, right? Now tell me, students, which will not possess the reducing property, right? Which of the following will not represent the reducing property? Down the group it is increasing. So H2O, like this. Okay. So minimum reducing property will be for H2S, and it's so less that it will not exist only, right? There is no reducing property of water. So answer will be A is the correct, B is the correct answer, right? Okay. Yeah, this is group wise. Hydrides we are talking group wise only, right? This is group wise only. This is group wise. Okay. Group wise. Chalo. Now, next is which of the following hydrides have lowest boiling point? If they ask you the lowest boiling point, then which of the following will have the lowest boiling point? Same as group number 15. What should happen? The boiling point should increase down the group. But H2O has maximum. Reason being hydrogen bonding. Reason is hydrogen bonding. That is why from this oxygen is already eliminated. So the lowest will now be of sulfur. So answer will be B is the correct answer. Okay? Right? Okay? Okay guys, there are questions. So there are like very few questions are left. Right? Like we have completed 70%. 70% we have completed, right? So 30% we are left with, right? Mostly from block chemistry, so I can guarantee that from this only you will see some question in the exam, right? I can guarantee you that, right? You mark my words now, right? There is no other question that they can make out of. They will not create some new exception now, because everything they are asking, you are doing the question, you are doing all the exceptions here. There's not even one exception that they have not asked in the previous years, right? Okay, chalo. Next is, acha, this is the table of your NCERT only, right? This I have already taught you. Next is which of the following hydrides show highest boiling, this is the repeated question, highest boiling point. Beta, highest boiling point, now only I have told you the highest boiling point, right? Highest boiling point, so I have told you now only. In NH3, highest boiling point is not shown by NH3. That will come in the middle, right? But in H2O, the hydrogen bonding is so strong that it will have the highest boiling point, that is H2O will have the highest boiling point, right? Okay, chalo. Exceptions are limited. Exceptions are not limited, but the NEET paper they have asked so many times that almost all the exceptions are like, we are done. We don't have some new exceptions now, right? I think if some researcher would have come up with some new exception, they would have given you that only, right? Now, the stability of the halides in organic chemistry is actually very hated because of the exceptions, isn't it? Right? Chalo. Now, next is the stability of halides of group 16 elements decreases in the order. Right, guys? Decreases in the order. I want every one of you to answer this. Decreases in the order. Stability of halides, group number 16, we are talking about the halides decreases in the order. Group number 16 halides element decreases in the order. Beta, the stability of halides, whatever group you talk about, they will decrease down the group, right? Fluorine, chlorine, bromine, iodine. It will decrease down the group. The stability of halides will always decrease, right? Because of the electronegativity and the size. So answer will be fluorine will be maximum stable, then chlorine, then bromine, then iodine. So answer is going to be C is the correct answer. Right, very good. Group size priority, right? Okay, chalo. Next question you have, which is the number of sigma and pi bond present in sulfuric. Now again, the oxo acids of sulfuric acid. See, oxo acids of phosphorus are more important as compared to oxo acids of sulfur, right? But some of the acids you can do. For phosphorus, so I would say all the oxo acids, see the structure, okay? But for sulfur, if you want to see only the previous year question, that will also work. Okay. So if you talk about the sulfuric acid, right? Sulfuric acid, so we all know the structure of sulfuric acid, na? H2SO4, right? H2SO4, right? So this is having OH here, OH here. This is the structure of sulfuric acid. Now they are asking you number of sigma and pi bond. This question can be asked to you. Right, this will not be out of syllabus. Yeah? Who doesn't know the structure of H2SO4? Even if you don't know, sulfur is having 6 bonds. Now here. Now they're asking sigma. 1, 2, 3, 4, 5, 6. 6 sigma bonds, right? Then you have 2 pi bonds. Right? So answer is A is the correct answer. Right? Okay, yes. The king of the chemicals. Yes, very good, yeah. King of the chemicals. Right? Next, student, we have which of the following oxo acids for sulfur has OO bond, right? Now, here so you need to see the structure of the sulfur for the oxo acids of sulfur. If you see the structure here, these are the 4 structures directly from your NCERT, right? So basically, if you have wait a minute, there was H2SO4. So if you see the structure of H2S2O8, that is peroxo disulfuric acid. Peroxo disulfuric acid. Basically from the sulfuric acid, right, you have taken out water here. That is why it is having this OO linkage here, right? Okay. So if from the sulfuric acid, if you see this acid here, right, if you see this acid here, for example, you have one more molecule like this, this is S double bond O, this is OH, this is OH, you take out water from here, wait a minute, you take not water, you take out HH from here, you will have this kind of linkage. This is called your peroxo disulfuric acid. Okay, peroxo because it is having that bond here. So answer is B is the correct answer. Okay, next is based on which oxo acid of sulfur that does not contain bond between sulfur atom, right? Again, which will have the sulfur oxygen bond here, right? Okay, so if you see, let me just show you the structure here. Which does not contain the sulfur bond. So now that does not contain bond between sulfur atoms, है ना? Bond between sulfur atom it is not containing. This is containing the bond between sulfur atom. This is containing. This is also containing so many bonds. So pyrosulfuric acid or oleum that does not contain bond between the sulfur atoms. Okay, so that is why this becomes very important. Here we are taking out, wait a minute. Here basically two molecules of, just let me show you this thing here. If from this side you had OH, you had OH here. If you take out water from here, then you would have oleum here, right? If you take out H2 here, then you would have peroxo disulfuric acid, right? So that is why these are basically derived from H2SO4 only. That is why these becomes important for you, right? That is why knowing the structure of this becomes important for you, right? Okay, oleum, so you need to remember, sulfuric acid you need to remember. And if you take one H2 from that, that also you need to remember. So these three structure, remember these three structure. If you want to skip the other structures, you can skip, but remember these three structures, okay? Right? Chalo. Now, next is, this also we have done. Now, bleaching action of SO2, right? Basically, they will not ask you the reactions here. This I have picked out because they can give you a hint and ask you such kind of question. That is why I know that this is, some students are like, ma'am, I don't want to study P block. For them, I have picked out these questions because at least do these questions, yeah. Okay, if you are trying to read full P block NCERT, that is great. But if you are thinking that I'll only do the exceptions, then also do these kind of questions, okay, right? You never know, same question is asked, okay? Bleaching action of SO2 is due to oxidizing property, acidic property, reducing property, or the basic property. Yes, guys. Bleaching action is due to which thing? SO2. Usually students, they will just pick this, that okay, bleaching action, it may be oxidizing property, right? Bleaching action here is due to the reducing property of SO2. So answer is C is the correct answer. Okay, one word answer it is. Right? Chalo. Now, which acid has peroxo linkage? Now, here also, which is very important for you to learn the 𝐤𝐤 acid structure. Okay, the structure of 𝐤𝐤 acid. That is why I have brought up this question for you. Right? So, peroxy linkage is basically in 𝐤𝐤 acid, and 𝐤𝐤 acid is this thing only. Wait a minute. Let me show you the 𝐤𝐤 acid. Right? Okay, ye raha. Okay, this is the 𝐤𝐤 acid. So, this is the 𝐤𝐤 acid, as you can see here. In sulfuric acid, you have one more oxygen, right? You have H2SO4. But if you have H2SO5, this is called your 𝐤𝐤 acid, okay? This is called your 𝐤𝐤 acid, which has a peroxy linkage. Got it? Yes. So, that is your 𝐤𝐤 acid. This is very, very important. This is an important acid. Name is very important, right? Okay, chalo. Next we have, now we have simple questions, okay? Till here though I was telling you those questions. If you want to skip the compounds entirely, then you should do these questions at least. Now again to the exceptions and everything, right? Okay, so now electron gain enthalpy with negative sign of fluorine is less than that of chlorine due to. Yes, students, electron negativity, the electron gain enthalpy with the negative sign of fluorine is less than that of chlorine. What is the reason? Because I told you that fluorine is having same question is repeated. Fluorine is having very small size. This they have asked for nitrogen as well, right? This they are asking for oxygen as well. Now this third time they have repeated this question, same question from group number 17. That means the same question is repeated again and again. Same question, okay? So here it is due to the smaller size of the fluorine. It is not able to accept the electrons, right? It is not able to accept the electrons. Next is the correct order of increasing oxidizing power, right? The correct order of increasing oxidizing power, guys. Increasing oxidizing power. Right? Very good, very good, very good, very good. The correct order of increasing oxidizing power. Oxidizing power. Okay. If you talk about the oxidizing power, we know that fluorine is the most electronegative element. है ना? It will have increasing order of oxidizing power to oxidize. It has a good reduction potential, right? Fluorine has a good reduction potential. Okay, it can be D, it can be D because fluorine, if you talk about fluorine, it is most electronegative element. Now, most electronegative element will try to gain the electron. It will make the other person lose the electron. It will oxidize something else. So, it is a very good oxidizing agent. So, that is why the order will be this. Right? Down the group, oxidizing power will decrease. Okay? So, answer will be D is the correct answer. Next is, in the case of alkali, now guys, we are talking about in the case of alkali metals, the covalent character decreases in the order, right? Okay? Yes, everyone? In the case of alkali metals, the covalent character decreases in the order. Alkali metals, okay? This is based on Fajan's rule. Na? Okay. Metal, they are talking about alkali metal that is having +1, +1, +1, right? So there is no talk about the charge, but this is fluorine, chlorine, bromine and iodine. The size, hai na? So if you talk about, wait a minute, if you talk about fluorine, chlorine, bromine, iodine, fluorine, chlorine, bromine, iodine, fluorine, chlorine, iodine, bromine, this is eliminated. Chlorine, iodine, bromine, fluorine, chlorine, this is also eliminated. Either this or this, right? So now we know that size is decreasing. Anionic size is increasing. They are asking you the covalent character, right? They are asking you the covalent character. So more is the size of the anion, more is the ionic character, right? Okay. So if you talk about the ionic character, this is having more size, so Mi is going to have the maximum ionic character, covalent character, right? Right, more is the size, more is the covalent character, so Mi is going to have the maximum. Then you have Mbr, then you have MCl, then you have Mf. So size will basically dominate here, so answer is going to be C. Hai na? So because they are asking you the covalent character. For the ionic character, the answer would be this. For the ionic character, the answer would be this. This is for covalent character, right? This is for covalent character. For covalent character, as you can see that here for the covalent character, as size increases for the anion, right? Covalent character increases. But for ionic character, more is the size, less is the ionic character. Okay, that is opposite. More is the cationic size, more is the ionic character. Less is the anionic size, more is the ionic character. Right? Okay. Now, next is, if you have which one of the following order is correct for the bond dissociation enthalpy of halogen. Now, we are going to talk about bond dissociation enthalpy, guys. Bond dissociation enthalpy. This is also an exception. Okay, this is also an exception. Write it here. This is also from the exception. Now, down the group size is increasing. So, what is supposed to happen? That this is fluorine, chlorine, bromine, iodine. Down the group size is increasing. So, bond dissociation enthalpy is going to decrease. Right? That means it should be fluorine, then chlorine, then you have bromine, then you have iodine. But in reality, because this is having the maximum, but in reality, because of the electron repulsions, right? They can also ask you this in the form of assertion reasoning. Because they will level up this question, na? So they can ask this in the form of assertion reasoning. That is why I'm also giving you the reasons side by side. Just you need to cram this, okay? You also need to know the reasons here. So electronic and electronic repulsion, the size is very small. Because of that, because of the repulsion, it will be easy to break this. right? So fluorine having the maximum, that is going to be not the correct answer, right? This is fluorine in between, chlorine. This is also not. Fluorine is the minimum, that is also not the correct answer. Fluorine will be in between. Fluorine, the chlorine, bromine, then you have fluorine, then you have iodine. है ना? I think B is the correct answer, right? Because you have chlorine, bromine, that is same, chlorine, bromine. In between this iodine, in between this fluorine will jump. So it will be fluorine, then iodine. So B is going to be the correct answer. Okay? Got it? Chalo everybody, next question on your screen. Next question on your screen. Let us see how many questions we are left with. Very few questions, so there is no use of taking the break, okay? There is no use if I give you the break, right? What will happen? 20 minutes I'll give you the break. Hana, you will wait for me. Then 20-minute topic is left, right? So there is no use of giving you the break, right? Okay, let's finish off this topic, right? Okay, chalo. So that we can have our dinner and with relaxed mind, okay? So now here the question is, which of the following order is not according to the property stated is? Property that is being stated here, which of the following is not correct according to that? Okay, which of the following is not the correct order according to that? Acidic property, we know that down the group, which is not the correct, na? Acidic property in water. In water they are talking about, right? So down the group acidic nature reducing power increases, right? This is the correct. This to always increases. Reducing power, this is true. If you talk about electronegativity, it decreases down the group, that is also true. Bond association enthalpy. Here we have just done the bond association enthalpy in the previous question. Hai na? Fluorine was not here, fluorine was here, right? So this is not the correct order. So this is the correct answer. Oxidizing power, it decreases, that is also true. So answer is C. Same question, see? Same question, same question. Okay, this is how same question is repeated in the exam. This is the same question, this is the same question. Right now, they are focusing more on these kind of questions where they can ask you from one question, they can ask you so many questions. 4 questions they have asked in one question only, right? So right now, the focus is more on these kind of questions, right? The correct increasing order of acidic strength. If you talk about the acidic strength, guys, everyone, acidic strength, I told you hydrides, same question, same question, same question. Acidic strength will increase down the group, right? It will increase down the group. So answer will be B. Same. This is same. From this and the last question is same, right? 3 questions, similar concepts, right? Okay, that means in this question, they have asked 4 questions. Individually, they have asked this. Individually, they have asked this, right? Now, they can even ask you oxidizing power. They have also asked oxidizing power individually. Electronegativity, they have asked individually. So, can you see that from one question, right? Are you getting an idea what kind of question they will ask you in the exam? What kind of question will be there in the exam, right? Okay. At room temperature, HCl is gas while HF is again the same question. We have done this in H2S, right? In H2O, H2 is liquid, H2S is gas. Same question they're asking. HCl is gas while HF is low boiling liquid because of hydrogen bonding, right? So answer will be HF has hydrogen bonding, right? Okay. Very good. Same question. See. Next is the correct order of decreasing acidic strength. The correct order of decreasing acidic strength here. Acidic strength. This is acidic strength in these kind of things now, where you have oxo acids. Here oxidation number is directly proportional to acidity. Right? So you just need to calculate the oxidation number. Exception is phosphorus. In phosphorus, you have to see monobasic, dibasic, that is the exception. Okay. So here oxidation state you have to see. Oxidation state, guys, if you see, what are the electrons? HCl you have -1 here. This is +1 plus x minus 4 equals to 0. X is equals to 3, right? So basically this will be 3, right? This is +1 plus x plus -6 equals to 0. X is equals to +5. This will be +7. But if you want to calculate this, +1 plus x minus 8 is equals to 0. X is equals to +7. Right? So here, as you can see, oxidation state is increasing. More is the oxidation state, more is the acidity. So HClO4 is going to have the maximum, then HClO3, then HClO2, then HClO. So answer is going to be B is the correct answer. Okay, B is the correct answer. Got it, guys? Okay, everybody. Chalo, beta, almost we have done like 100 questions we have done. 100 questions we have done. Can you even imagine that? Right? So when you are alone, you are just thinking that I'll do 100 questions, right? This and that. But now we have already completed that. Okay? Rest of the questions also we are going to do maybe in 20 minutes. Right? Now, next is match the following. Now, guys, you don't need to cram this. Okay? So what you need to do, we know that X and X. We know that XX means X is having 7 electrons. It is forming only one bond. Right, 1 electron is eliminated, 6 electrons. That means 3 lone pairs it is forming. So it is having 3 lone pairs plus it is having 1 bond pair. Total it is 4. So it will form tetrahedral shape. So X and X will have tetrahedral shape. That means 1 is going to have fifth. 1 is going to have fifth. Already we know the answer C. Right? Already we know the answer. Wait a minute. 1 is going to have X and X, 7 electrons, 1 electron is here. That is why 6. So 3 lone pair it is having, 1 bond pair it is having. Acha, they are asking you about the shape, not the geometry. Wait a minute, they are asking you about the shape, not the geometry. So the shape is going to be, if you talk about the shape, here for example, you have X, then it is going to have 3 lone pairs and this is X dash. So shape is going to be linear only, not tetrahedral. Shapes they are asking you. So 1 is going to be 3, right? So C and A are eliminated. Sorry, C, this is also C. This should be B, right? B and C are eliminated. A and D can be the answer, right? Now let us talk about X, X3. X is having 7 electrons, 3 bonds it is forming. So it will be 4 electrons. That means 2 lone pairs, right? Now, 3 bond pairs and 2 lone pairs means total 5. 5 you will have, that means this kind of thing. But 2 lone pairs you have to accommodate, that means this thing. Shape will be T shape. Shape will be T shape. So 2 is going to be 1. 2 is going to be 1. Here 2 is 4. So this is also eliminated. Answer is A. But still we are going to see for third and fourth also, right? This is X, X5, right? So here this is X is 7 electron halogen, 5 bond it is making, 2 electrons means 1 lone pair. That means 5 bond pair, 1 lone pair, that means octahedral geometry it will have. But shape is going to be 1 lone pair, na? So shape is going to be square pyramidal. That means third is fourth, right? Okay. What about this one? What about the last one? What about the last one? XX4. Beta, this is the best way of doing questions of hybridization, right? Here, it will take you seconds to solve the answer, okay? Now, this is 7. 7 electrons are consumed. No lone pair it is having, right? So, now here it is having no lone pair. 7 electrons are consumed. 7 bonds it is forming. 7 bonds means we know that when it is forming 7 bonds, it is pentagonal bipyramidal is the geometry. So, fourth will be 2. So, answer is A is the correct answer. Okay? Okay, chalo. Next is the shape of XeO2F2 molecule. This also we have done before as well. The shape of XeO2F2 molecule, guys. Xc is what? Having 8 electrons, right? How many bonds? See, with oxygen, it can form 2 bonds. We know that oxygen can form 2 bonds. Fluorine can. Firstly, though, whenever you are predicting the shape with oxygen, just draw a random structure. 1, 2, 3, 4, 5, 6. 6 electrons it is using. Though it is 4 atoms, but with oxygen always form double bond, right? So, 2 electrons are left. That means 1 lone pair. Total what we have, bond pairs are, in bond pairs only calculate sigma bonds. 1, 2, 3, 4. 4 bond pairs plus 1 lone pair. So it is going to be 5. That means the geometry is going to be trigonal bipyramidal. But here we need to have 1 lone pair. 1 lone pair will be over here. So this is Xc. This is double bond O, double bond O. This is F, this is F. So it is your seesaw shape. So answer is going to be D, seesaw shape. Okay, it is going to be D, seesaw shape, not square planar beta, not square planar. Firstly, you have to see what is the number of bond pair plus lone pair. Bacha, the geometry is trigonal bipyramidal. Okay, geometry is trigonal bipyramidal. Lone pair to we will not consider in shape. You can see a seesaw structure here, isn't it? So answer will be D. Okay. So these are very, very important things. Okay. Usually students lose marks in hybridization and shapes only. And this is the topic that I can guarantee that questions will be asked. Right. Among XCO3, XCO4, XCF6, the molecules having same number of lone pairs. Same number of lone pairs, guys, now we are looking for. Right. Okay. If you talk about XCO3, here Xc is having 8 electrons, 6 bonds, 6 bond pair it is using with the oxygen. 1 oxygen is going to make double bond. Always oxygen forms double bond. 6 electrons will be consumed, 1 lone pair. 1 lone pair. Okay. What about XCF4? XCO4. XCO4 again you have 8 electrons, right? Okay. It is forming 4 is 8, so there will be no lone pair, right? What about XCF4 will have 1, 2, 3, 4, 5, 6, 7, 8, yes. XCF6, it will have what kind of lone pairs? It will have 8 minus 6 electrons. So it will have 2 electrons, that means 1 lone pair. So lone pair will be same for XCO3 and XCF6. XCO3 and XCF6. So answer B will be the correct answer. Okay. B is going to be the correct answer. Okay. B is going to be the correct answer. XCF4 is going to be square planar. XCF4 nahi beta. XCF4 to we are done. XCF4 is not here. Okay. So here answer is, wait a minute. XCF6, okay. Here the question is wrong, yeah. The question is wrong, okay. Here they are typing something else and the question is given something else, okay. So here XCO4 will have a different, that is true, but here the options are wrong only. Even the question is wrong. So let me correct it here, okay. But let me see XCF6. XCF6 will have 6 electrons will be taken out. Acha. Geometry will be, geometry will be that only. 1 lone pair, it will have 1 lone pair. It will have 1 lone pair, right? This will have no lone pair, right? If you see this question, firstly, so if you see this question, this is not going to be the correct answer what they have written, okay? This is typing mistake, guys, right? So here the answer is going to be not this, but XCO3F6, that is B is going to be the correct answer, okay? B is going to be the correct answer, okay? Not D. Got it now? Why? Got it now? Now they were giving you one question, that is XCOF4. That was given here, na? XCOF4. So we'll see that how to draw the structure of XeOF4. That is not there in the question, but still because we have seen that over here mistake was there. So just some students who are curious, for them. Xe is basically, guys, this is 8 electrons, 2 bonds with oxygen, 4 bonds with fluorine, total 6 bonds. So that means electrons, 1 lone pair. 1 lone pair will be there, right? That means Xe is having 1 lone pair. Bond pair plus lone pair is sigma bond pair. Sigma bond are, because Xe will have 4 fluorine and 2 oxygen. 2 oxygen. So 1, 2, 3, 4, 5, 6. 6 plus 1, that is 7. Whenever you have 7, that is for trigonal, that is for pentagonal bipyramidal. So this will be Xe, right? This is trigonal bipyramidal, means 4, 5, 6. So it will be pentagonal, not trigonal, pentagonal. So it will be double bond over here, fluorine, right? Fluorine, 1 more fluorine. Okay, 1 more fluorine. So it is a pentagon here. It is in one plane only. It is in one plane only. After that, you will have 1 lone pair over here, right? 1 lone pair over here that we have drawn. Okay, understood? So that is going to be, geometry is going to, the shape is going to be pentagonal only, pentagonal planar, but the geometry is pentagonal pyramid, bipyramid, pentagonal pyramidal. Okay, got it? Got it, students? Chalo. Now last 5-6 questions we have. Magnetic moment. Now beta, they are asking you the magnetic moment. 2 point. Now just remember, whatever is written before the point is the number of unpaired electrons, right? So here 2 is written, means unpaired electron should be 2. So you need to calculate the unpaired electron here. Draw this here. Okay, you just need to write the unpaired electron, right? This is 22, this is chromium is 24, this is cobalt is 27, nickel is 28. This always, it will have argon, 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 argon. This will have 4s2, 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 right? This number that is represented here is your d electrons. So this is 3d, 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 3d. This is 2, 4, 7, 8. But chromium has an exception. Chromium, 1 electron will jump here to D for half filled, in the greediness of half filled electrons. Now you have to take out 2 electrons, 3 electrons from here. After taking out 3 electrons, it will become 3d1. Taking out 3 electrons, it will become 1, 2. After taking out 2 electrons, it will become 3d4. 2 electrons, it will become 3d7. 2 electrons, it will become 3d8. You need to have 2 unpaired electrons, right? 2 unpaired electrons, definitely the possibility is not here, right? Possibility is over here. So as you can see, 1, 2, 3, 4, 5, 6, 7, 3 unpaired. 1, 2, 3, 4, 5, 6, 7, 8. 2 unpaired electrons. So answer is D is the correct answer. Okay? Okay? Okay, students. Now, next is which one of the following does not correctly represent the correct order of property indicated against it, right? So 4 properties are represented here. You have to tell which is not representing the correct order of property, right? From DNF block, specific questions are asked, right? If you talk about the increasing number of oxidation states, see, because the unpaired electrons are increasing, that is why increasing oxidation state will be down the group only, right? We know that manganese is showing at least from +2 to +7, it is showing so many oxidation states. If you remember that table in your NCERT, it is like this. Manganese is showing the maximum number of oxidation state. So it is increasing and again it will decrease from there, right? So this is the correct order, right? Then you have increasing magnetic moment. Say magnetic moment, so you have to see here, right? magnetic moment, so you have to calculate here, right? Melting point, increasing melting point, and this is I2, right? See, if they are asking you the incorrect statement, so directly you can tell that increasing melting point is the incorrect. If you know that what is the correct order of melting point, then you can easily tell that, okay, increasing melting point is not the correct answer. But if you want to solve it, if you don't know the melting point order, you are still confused about it, then obviously you can do this with the help of elimination also. Because magnetic movement, so you will be able to calculate just like we have calculated here, right? So melting point, magnetic moment you can calculate, and it will be this only. It will be in this order only. And increasing IE2 will also be in the same order. Also be in the same order. That is why incorrect order is C is the correct order. C is the correct answer. Right? Next is we have out of TiF6 2 negative, CuF6 3 negative, CuCl2 and this, the colorless species, that means the one which is having D0 or D10, that is a colorless, okay? The one which is having D0 and D10, guys. So, if you want to calculate it, if you want to see this here, it is x minus 6 is equals to minus 2, x is equals to plus 4, right? So, this is basically 22, it is 4s2, 3d2. If you take out 4 electrons here, it will become 3d0. So, TiF6 2 negative is definitely, it is D0, it is colorless. So, either this or this is the correct answer. That means these are not the correct answer. Now, let's see CuF6 and Cu2Cl2. Let's calculate for Cu2Cl2. This is 2x minus 2 is equals to 0. 2x is equals to x is equals to 1. You will x will turn out to be 1 here, right? Now, the next thing is x is turn out to be 1. Now, what you need to do next? X will turn out to be 1. That means copper, which is 29, which is 4s, 4s1, 3d10. You take out 1 electron, it will be 3d10. That is fully filled, है ना? So, this is fully filled. So, this condition is justified here. So, answer will be B is the correct answer, right? Okay. Chalo. Next question is based on the monooxides here, right? And it says that the basic character of transition metal monooxides follows the order this, right? Now, which is the basic character they're asking now? Wait a minute. Basic character. T V kar manfi. V kar T. This is not correct. Kar V Phi T. T Phi. This is like a weird. This is not a, means this is following a general trend only, that the melting point is going to decrease, right? Because that depends on the unpaired electron basically, right? So here it will be Ti2 positive, this is V2 positive, this is Cr2 positive, this is Fe2 positive, right? Okay, so T, Phi, V, Kar, that is also not correct, right? So basically down the group it is decreasing, right? So here T, V, Kar, Man, Phi. So answer will be A, है ना? So answer will be A is the correct answer, okay? Next is again on the basis of acidity, basicity. Acidic, basic, amphoteric nature of Mn2O7, V2O5 and CrO are respectively, right? Very, very important oxides they are. Very, very important oxides, guys. So firstly, to remember that zinc, aluminium, lead, tin and vanadium. What I told you? Zinc, aluminium, lead, tin and vanadium. These are amphoteric oxides, right? So amphoteric. So this is amphoteric. So this will be eliminated. This will be eliminated. Now, if you talk about Mn2O7, that is basically Mn2, your oxidation number here is 2x. Oxidation number, so we don't need to calculate because they are different, है ना? Because this is different, this is different. Now we don't have to calculate the oxidation number. This is Karman. So if you see this here, right, manganese is going to be acidic, right, and chromium is going to be chromium 2, right, because it is also in very less oxidation state, +2 oxidation state. If you calculate this thing here, 2x minus, here the oxidation state will also matter. This is 14 is equals to 0, 2x is equals to 14, this is 7, x is going to be 7, right? So definitely this is going to be acidic, this is going to be basic, right? So here this is going to be acidic and this is going to be basic. So answer will be C is the correct answer. Okay? Okay guys, chalo. Now next question is, they are asking match the catalyst here. Now you have to match the catalyst here. This question is also very important, asked from directly the application part. Okay? Directly asked from the application part. Chalo. Now, if you talk about vanadium oxide, right? Okay, vanadium oxide is used where? Ziegler-Natta catalyst, TiCl4. Here they can also write Ziegler-Natta catalyst, that is the same thing, right? PdCl2, nickel complexes. Okay, so everybody, if you talk about vanadium oxide is used in oxidation, no polymerization. It is used in contact process, that is oxidation of SO2 in the manufacture of H2SO4, right? So one is C. So this is eliminated, either this or this. Then you have Ziegler-Natta catalyst, right? The oxidation of Ziegler-Natta catalyst, oxidation of ethyne to ethanol, polymerization of alkynes, polymerization of ethylene. So basically Ziegler-Natta catalyst is used to convert ethyne to ethanol, right? Okay, so here it will be 2 is 1, right? Okay, so answer to we know that A is going to be the correct answer, right? PdCl2 we know that this to we use in polymerization of ethylene, right? So this is D, and fourth is nickel complexes, polymerization of alkynes, right? So it will be fourth is B. So this is from your application part, right? Okay. Wait a minute. Ziegler-Natta catalyst is used in polymerization of ethylene. No. Okay. Ziegler-Natta is used in polymerization of ethylene. Okay, if you see this thing, Ziegler-Natta is used in polymerization of ethylene, then PdCl2 will be used in oxidation of ethyne to ethanol. Okay, then nickel complexes are used in B only, that is your polymerization of alkynes. So this is where we did the mistake. है ना? Ziegler-Natta catalyst, it is used in polymerization of ethylene. Okay, so this is actually very confusing because this is used in polymerization of ethylene and this is used in polymerization of alkynes. Okay, third is used in, wait a minute, this is used in, wait a minute. Fourth, nickel complexes are used in polymerization of alkynes. This is used in polymerization of ethylene. This is used in oxidation of ethyne and ethanol. Basically, I'll tell you, this is from the last paragraph of DNF block, right? From there, as it is line by line, they have mentioned this also, this also, this also, this also, right? Okay, so yes, my bad, answer is B. Again, your cramming question, so even I get stuck in, right? This is full on cramming. Wherever I feel that there is cramming, then I feel like, oh my God, how to do this? But you have to gain the marks, okay? You have to cram things. I can't change the education system, na? Right? So which of the following lanthanoids is diamagnetic in nature? Diamagnetic means it should have no unpaired electrons. No unpaired electrons should be present there, right? No unpaired electrons should be present there. So which of the following is having unpaired electrons? So you need to see the electronic configuration here. So let us directly see the electronic configuration. So basically it is, if you have SM2 positive, it is atomic number they have given, that is 62. This so they will give you at least, hai na? Because they are asking something from lanthanoids, then they will definitely give you the atomic number here. So atomic number they have given to be 62. Now we know that here the electronic configuration is 4s6 6s2, right? 2 and 6, right? 63 it is 4f7 6s2. 70 it is 4f14 6s2. And for cerium it is 4f1, and this is a very, very important electronic configuration, right? Even this is also very important. Even this is also very important. These are, gadolinium is also very important electronic configuration, right? So these are some of the important electronic configuration from where directly the questions are asked. Okay, so this is basically they were asking you is diamagnetic. So diamagnetic is YB2 positive. So answer is C is the correct answer. Okay. Now as I told you that gadolinium is a very, very important compound. So from here, right, they can, this too they have asked you so many times, the electronic configuration, right? The electronic configuration to gadolinium is asked so many times, right? Reason is because in this also it is fully filled. EU2 positive is half filled. That is why these two become very, very important for you. Then in gadolinium also you will see half filled configuration. So I have already given you the hint, right? That is 4f7 5d1 6s2, right? Okay, that will be the electronic configuration of gadolinium, right? Okay, but remember here it was 2 positive. Here I was telling you that why EU2 positive exists, why it will exist in YB2 positive, why cerium will exist in 4 positive, because here it does not have fully filled, here it does not have half filled or 0 or fully filled electronic configuration, but after losing 2 more electrons it will have, right? Okay, after losing 2 electrons it will have 4f0. So that is why cerium is more stable in 4 positive, europium in 2 positive. That is also very important. Okay, chalo. Now next is the correct order of ionic radii is ionic radii, right? So ionic radii, guys, first thing is lanthanum also they have taken, है ना? Lanthanum also they have taken here. Chalo. Lanthanum, this is basically what will happen now. But let's arrange them in the order. Y, this is La, this is Eu, this is Lu, right? Lu. This is the order. This is the end of lanthanoid series, the starting, right? And this is not in that. This is not included in the series, right? Okay. So from here, we know that, basically we know that in lanthanoids what will happen, right? In lanthanoids, so if, because firstly though we need to see about lanthanoids, okay? Definitely this is not the lanthanoid, this is group 3rd element only, but we will take it as lanthanoids only. So in lanthanoids what happen, usually the size is very weird, right? But here we take the general trend that here the size is decreasing, okay? In 4F series the size is decreasing. So that is why if you talk about La, then you have Eu, then you have Lu, lutetium, right? Okay. Now what about this Y? Here it is going to have the minimum size or the maximum size, because it does not belong to this series, right? Okay, this does not belong to this series, so I think it should have the minimum size only, right? Let's see this here. La is maximum, Eu then Lu. Either this can be the answer or this can be the answer. Others are not going to be the answer. So this is eliminated, this is eliminated, right? Now the question is whether 39 will have the maximum atomic number or not, right? Here the size is decreasing because of lengthenoid contraction. But if you go down the group, like generally if you go down the group, right? So basically it's like this now, it's like this. You have La, you have Eu. This I'm just drawing it like, say, this is basically your, from this you have the starting of 4F. This is down the group, right? This belongs to the D block. Now down the group we know that atomic size increases. So if you compare these two, definitely down the group size is increasing. That means lanthanum will have more size here, right? If I had a more size, so this will not be possible. So answer will be C is the correct answer, okay? So this is how, by applying different concepts that you have learned, you can get your answer, right? So firstly, though, you need to see the positioning of the elements. By lengthenoid contraction, it is decreasing. Yes. Now, we know that from here, the size is increasing, right? Okay, that is why the answer is C is the correct answer. Okay, C is the correct answer. Okay, regular decrease, and because of this, here you have the increase. Okay. Chalo. Now, next is which of the following statement is not correct? Which is not correct, guys? LaOH thrice is less basic than LiOH thrice. Okay. Li, lithium. Okay. La is actually an element of transition series rather than lanthanoids. Yeah, that is true. That is true. They are asking the incorrect. Atomic radius of zirconium are basic because of lanthanoid contraction. That is also true. In lanthanoid series, ionic radii of Ln represents all the lanthanoids, ion decreases. That also I told you that ionic radii will decrease here, right? So this is also true. So incorrect option is only this one, right? So LaOH thrice, Li3 positive. Yes. So this is more basic. It is less basic as compared to Li this. That is a wrong statement. LiOH thrice is going to be less basic as compared to LaOH thrice. Okay. So answer is going to be this, right? Okay. So this is La, this is more basic than LiOH thrice. This is what I have written here, right? In lanthanoids, the basic character of hydroxides decreases, the ionic radius decreases, right? So answer will be A is the correct answer, right? How many questions here? 1, 2, 3, 4. Oh my God. Still we have 7, 8 questions. Okay. Now, next is the oxidation state of chromium in this and this and this respectively are. Oxidation states, guys, you have to calculate, right? Very simple. How do you calculate the oxidation states? See, in coordination compound, usually the questions are asked either simple topics are oxidation state, simple, any you can calculate. IUPAC naming also sometimes they ask. So very small topic, easily question can be answered, right? So this is basically plus 3. So it is going to be X plus 0 is equals to plus 3. So it is going to be chromium 3 positive, right? Oxidation state they are asking now. So this is plus 3, plus 3, plus 3, plus 3 everywhere. So this is chromium, right? It is going to be 0, I think, right? Okay. So it should be 0, right? Hai It should be 0 because C6H6 is what? Benzene. It is 0, na? Phenyl. So it is going to be 0. Again, you have 2 options. Now, you need to calculate for this one. Wait a minute. This is O2 or oxygen? This is chromium, right? Okay. This is chromium. This is going to be minus 2 here. X minus 2, right? This is going to be is equals to minus 2. So, this is going to be minus 2. X is this. Wait a minute. This should be CnO twice or what this is? If it is oxygen only, then it should be minus over here. No? If it is oxygen, this is basically minus 2. If this is only oxygen, see, Here you have O2. It is having 0. If it is O2 here, it should be -2 here. Right? So it should be x minus 2 is equals to 2 to 4 minus 4 is equals to -2. है ना? So here it is going to be x plus x minus 6 is equals to -2. X is going to be plus 4. -2, x minus 2, this is -2. Wait a minute, let me see. This is chromium, -2, -2. Achha, one peroxide linkage and one simple linkage. Wait a minute. One peroxide and one simple linkage is mentioned here. Wait a minute. This is the OO bond that is mentioned. This is the simple linkage that is mentioned. This is the peroxide linkage that is mentioned. So for one they have taken -1, for one they have taken -2. Then answer will be x minus 2. For peroxide linkage it is -1 multiplied by 2. For simple like oxide it is -2. Then it is going to be 2. Then again this is 0. Then this is a very good question. Okay. So it is equals to -2. Peroxide and simple oxide, this is 0 and that is chromium, this is -2. From here if you calculate, this will be 2, 3, 4, 4, 5, 6, 7, 8 is equals to -2. Then x is going to be plus 6. Answer is C. Okay. Okay. So basically this is a very, very interesting compound. Okay. Because peroxide linkage is mentioned here. Peroxide linkage is mentioned here. Right? Okay. Chalo. Now, next is as per IUPAC nomenclature, the complex this. What is the name of this complex? Firstly, so just see you don't need to calculate the oxidation state here because everywhere it is mentioned 333. So why to waste our time, right? Everywhere it is mentioned chloride, chloride, chloride. So just see what is different here. Now, this is tetra-aqua, tetraamine. Now, aqua will be first or amine. We know that amine because MnOPQ, right? M is before Q, right? So, tetra-aqua will be eliminated. Amine will be before it, right? Now, the second is here you have 1M, here you have 2M. Rest of the thing is right. Tetra-aqua cobalt, right? So, what you need to remember here, guys, that when you have ethylene, EDTA or EN, in that case it is AMINE only. But if you have simple NH3, in that case it is double M here, right? So answer will be D is the correct answer. Okay, D is the correct answer. Now, next question is, what is the magnetic moment of complexes here? Right, so here to very simple, you have to just calculate x minus 4, x is equals to plus 2. So cobalt plus 2 is what? 4s2, 3d7, right? So 2 electrons, this is 3d7. Spin only magnetic moment they are asking you, right? So plus 7 means 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, right? Okay. Magnetic moment, है ना? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. X is equals to plus 2. What is the magnetic moment? Spin only magnetic moment. For that, so you need to know the spin. Spin is going to be, they are not asking the magnetic moment. They are asking the spin only magnetic moment. Right? So, here if you talk about the spin here, this will be calculated by the spin. Right? If you talk about the spin, this will be cancelled. This will be cancelled. Here you have 3 unpaired electron. For these 3 unpaired electron, you will have the spin. Okay? For these 3 unpaired electron, you will have the spin, right? So here, if you talk about, this is going to be, this spin can also be cancelled. This spin can be cancelled by this spin. So only 1 plus half will be left here. है ना? Only 1 plus half will be left here. Right? So here, because they have not mentioned it in that order, magnetic moment of spin, only magnetic moment they are asking you to calculate. Right? Just give me a second. If they ask you this thing, spin only magnetic moment, right? For that, so you also need to see everything here. 3d7, right? If you have 3d7, it is a strong pairing. Yes, strong pairing. So it will be 1, 2, 3, 4, 5, 6, 7. Now, this is paired, because pairing will happen. Spin only means pairing you have to include here, right? So this is a strong field ligand. That is why pairing will happen here, right? So there is unpaired electron is 1. So it will be 1.7 something, right? So near to 1.7, the answer is 2. So answer will be 2. Okay. So for example, they would have given you a weak field ligand. Then we would have calculated 3. Okay. 3.8 something. But here, this is pairing is given to us, right? So spin will be cancelled by each other and you will be left with only one spin, right? That is half. Now, based on that spin only, you will get your magnetic moment, right? Not based on the other things which will be included in the pairing, right? Okay. So now answer will be this. Then you have the calculated magnetic moment spin only values for this one. Again, beta, the same thing they are asking you. FeCl, this is a weak field ligand, right? Okay. This is a very controversial ligand and this is so directly you can calculate, right? So try to answer this question, guys. Try to answer this question, guys. Everybody. So, here, if you talk about this thing, they're asking the magnetic moments here, right? Magnetic moments. For magnetic moment, what you need to see, that firstly, to FeCl4, right? FeCl4 is x minus 4 is equals to minus 2, x is equals to plus 2. So that means iron will be in plus 2 oxidation state. So this is 4s2 3d6. 2 electrons will be eliminated. It will be 3d6 only. So 4 electrons will be unpaired here. 4 electrons will be unpaired. So answer will be 4.9. So these two things are already eliminated. For 2, you don't have to calculate because it is mentioned 0 and 0 over here. For 3, you need to see that is going to be Mn x minus 8 is equals to minus 2, x is equals to plus 6. So here the answer is going to be manganese is what? Manganese is 25. So it is 4s2 3d5. You take out 6 electrons from here. It will be left with only 3d1. That is 1 point something will be the correct answer. So answer will 1.7 is going to be the correct answer. Answer is C is the correct answer. Okay. So C is going to be the correct answer. Got it? So that's it, right? So simply you can calculate the magnetic moment here as well. Now the hybridization and magnetic nature of this thing. MnCN64 negative and this. Hybridization and magnetic nature they are asking respectively. Acha. Hybridization and nature of this and this respectively. Are they going to be having the same magnetic nature? Kya? So let's find out. If you talk about this, x minus 6 is equals to minus 4, x is going to be plus 2. So that means manganese is going to be in plus 2 oxidation state, that is 4s2 3d5. It will exist only as 3d5. Strong pairing will occur here. So basically what will happen? Strong pairing will occur here 1, 2, 3, 4. 1, 2, 3, 4, 5. So definitely it is going to be diamagnetic. It is going to be paramagnetic, right? So answer can be B or D, and it is having inner octahedral, inner d orbitals are involved, so it will be D2sp3. Let's do the same for Fe also. I think the oxidation number will be same. That means the electronic configuration will be same. X minus 6 is equals to minus 3, X is equals to plus 3, yes. So iron is 26, so it will be 4s2 3d6. Take out 3 electrons. 3 electrons will be taken how? 2 electrons from here, 1 electrons from here. So answer will be 3d5. So that is the same only. So basically it is going to be D2sp3 and paramagnetic. Okay? Okay guys? Okay students? So answer is going to be this. Then last question of today is the same question that we have done before as well. Right? Okay? Same question that we have done before as well. Right? Before as well we have done the same question. So V2, let's see if I remember this or not. V2O5 is, that is so very simple, it is R. First is R, first is R. So that means this is eliminated, either this or this or this. Let's challenge Diksha ma'am. Your cramming is the worst thing that you will see. Right? Ziegler-Natta catalyst. Okay. Polymerization of alkynes, polymerization of ethylene. I know that PdCl2 is definitely this. Third is P. Third is P. Third is P. PdCl2 is the oxidation of ethine to ethanol. So 3 is P. 3 is P. 3 is P. 3 is P only here. This is not 3 is P. This is not 3 is P. So this is only 3 is P. So what about Ziegler-Natta catalyst? That is polymerization of ethylene, and nickel complexes are polymerization of alkynes. Right? So answer is A is the correct answer. Right? I still got confused between this thing and this thing because yeah, they are very similar. Right? Polymerization of ethylene. Right? But yeah, by elimination, so I have solved the correct answer only. Right? So A is the correct answer. Baki I'll see. Yeah, A is the correct answer. Right? So A will be the correct answer. Got it? Chalo. Ma'am, what about B? B was polymerization of ethylene. Z. I'll just remember. Okay, chalo, let's learn this along with Diksha ma'am. The students who are like Diksha ma'am, right? This is Ziegler-Natta catalyst. Z. Polymerization of ethylene. Z. ZTV you must have watched, na? Z. Polymerization, Ziegler-Natta is polymerization of ethylene, right? Nickel is alkynes. So it is nickel is to alkynes, so you can remember only, right? Okay, chalo. Done? Okay. So beta today's, so we have done like almost, I don't know, 250 slides it is. So I don't know how many questions we have done. I think maybe so 130, 140 questions, right? We have already done, right? So these were the most important questions of your inorganic chemistry. All the concepts I have covered here, right? Very important. It is same kind of questions you will see in your previous, in your exam also, right? Okay. Now, are you able to identify where you are lagging behind? Are you able to identify that particular thing? So I feel that some of the students, they might be lagging behind in exceptions, right? If your concepts are already clear, then there are high chances that you are lagging behind in the exceptions. Or maybe some students whose concepts are not clear, maybe they're lagging behind in hybridization and shapes also, right? So I want all of you to write it in the comment section. What are the areas where you feel that you are weak in, right? So I know my weaknesses. My weaknesses is wherever you see these kind of questions where there is proper cramming, like proper ABCD cramming, then I get very confused in that. So I know if I will be sitting in the exam right? I know I have to avoid those kind of questions because I know that I can do mistake there. I know that I am very good in conceptual questions, right? Very good in exceptions. So I will prefer those questions, because why I'm telling you that thing is, inorganic chemistry is that subject which is going to give you the marks, okay? So if you want to really good, like you want to score good marks in inorganic chemistry, then you have to be good in the theories and the exceptions and oxo acids of phosphorus. If you do these 3-4 things, then you will be like good to go, right? You have to identify which area you are weak in, right? Okay, you have to identify that. Physical chemistry we will do, in that you can identify your physical chemistry, right? So now I want all of you to write it in the comment section, what is the weak area in the inorganic chemistry. Okay, yes, chalo. Okay then guys, bye bye, take care, see you all in the next class. But before that, right, our batch is going on where we have live session, online test, online pedagogy, topic wise recorded lectures for you, right? That is coming from that is going from 5 p.m. to 10 p.m. right? Okay, so continuously daily the lectures are going on there, right? So for example, you have identified your weaknesses. Now what you need to do, you need to work on them. So you can work on your weaknesses over here in this particular batch, right? Okay, in combo batch you will also get all India test series, and in pro batch you will also get crash books and the doubt app here, right? So it's totally choice depending upon what you need, depending upon how much you need. For example, you know that you have a lot of doubts, then you should go for pro batch, right? So this is how you will be able to analyze yourself and work on yourself also. Now, one very important thing is that I have already told you before also, beta, in this particular session, what you will see that this particular session only, in the description, right, what you will see that here you have with get complete NEET preparation. Wait a minute. I think that was not added here, but don't worry, I'll add it here. Okay, I'll ask the team to add it here, right? Basically what will happen now, your PDF of 50 questions will be there in the description here, which is your homework. Okay, so you just need to solve the questions that is given to you in the PDF that will be updated by tomorrow morning. Okay, chalo. Okay then guys, bye bye, take care, see you all in the next class, take care, bye bye.